Folks, greetings. Hello. So you want a delicious snack? You know, food for thought? Well, you can have a snack for thought too, right? Well, this is going to be that, but obviously there's no free lunch, so you're going to have to, put up with the spiel first. Greetings to everybody in the chat. Thanks for joining me. No idea what happened with the last stream. Ridiculous amount of people. All I did was call it made out of chocolate cake. I thought I would try the same thing. Anyway, let's get on with this. It's interesting. So I think it's interesting, so let's see. First, we're going to see this. The overall taste of this snack is, might be disappointing to some, is the brainwashing of the vulnerable. So the snack, I am not brainwashing the vulnerable. I'm going to show you the brainwashing of the vulnerable. Beyond any question of doubt, absolutely irrefutably, we're going to see evidence, damnable evidence, of the brainwashing of the vulnerable. First, we're going to start with this. I'll show you what the video is called. NASA's 2024 Artemis Moon Landing Mission Explained. And everything I showed today is for educational purposes. I'm just going to play a small portion that will help me lead into the next. The next I will play all the way through. You will be shocked. But let's go.
Saturn V rocket. It will be able to carry more than 26 metric tons of cargo to orbits beyond the moon, with later upgrades hoping to shuttle at least 45 metric tons. Once the SLS is completed, NASA says it will be the only rocket with the power necessary.
The woman is talking about the future. What you're seeing on your screen is not footage of some previous launch. It is brainwashing for the vulnerable. That's right. This that you're seeing on your screen has never been shot, filmed from the ISS or from any satellite about any mission to space, to anywhere. This is CGI. This is for the vulnerable people like the Wolfies and the Wallies and all of the other vulnerable people out there. Vulnerable people like this next person who has obviously been brainwashed. Now, one of the things that the dastardly will do is brainwash the vulnerable and then use the vulnerable as a human shield. If you criticize the entity, well, you're criticizing the human shield. Watch. Faces of Technology.
I want to help people. I can't help it. I like comfortable books on the internet. So it's ridiculous. My sophomore year of college, I heard about a program which places people with disabilities in high-level internships. And lucky me, I got to do an internship here at NASA, and I've been working on SUV for the last 3 years. Astronauts have to do surveys of the ISS, and it takes them a bit of time. If we can create a payload for SUV to do that, then that would free them up to do more science. Everyday task can be hard for me, so I really wanted to dedicate my work to making robots that can really help us in life.
This poor young woman has been brainwashed into thinking that she can code a robot in outer space to help the everyday life of astronauts in outer space. Now, obviously, I'm not saying people with cerebral palsy or other disabilities should not have the possibility of a career in whatever field they can make it in. That's absolutely not what I'm saying. But what I am saying is that it would be better if vulnerable people, like the young woman you're seeing on the screen, were not wasting their time programming fantasy ideas and were instead programming real implements that would help real people, which is what she thinks she's doing. She could be coding motorized vehicles for the disabled, for helping people who are disabled, which is what she wants. She wants to make people's life easier, especially people who find everyday tasks difficult. That's the purpose of this. This is to brainwash the vulnerable. Now, if anybody would like to argue with me regarding whether or not this young woman is vulnerable, then please put it in the comments. Now we're going to look at further brainwashing. How far is the edge of the universe? We're going to watch these two videos. How far is the edge of the universe? First, that's an incomplete question. How far is India? You see what I mean? And then we're going to watch this one. If the universe is only 14 billion years old, how can it be 92 billion light years wide? This is abusing, brainwashing the vulnerable. You see, the non-vulnerable will say, whoa, hold on a second, what you just said contradicts what you said earlier. But the vulnerable will not. And the point of this, what we're going to see now, is to brainwash the vulnerable. Because those same vulnerable people, if they're not brainwashed into pushing this propaganda, they could be brainwashed into working with, I don't know, Tesla technologies. You know, who knows? If they're capable, then they might end up, getting themselves in trouble by making an accidental, free energy device or something like that. So let's watch this. By the way, wait. What you're going to see, I know the majority of flat earthers watching this are going to see it as parody. But you have to imagine seeing it from the point of view of the globeling who does not know that this is complete gibberish, who will try to keep up with what's being explained. This is not parody. If I did the same, in fact I did something like this with Jeranism some time ago, pretending to be Brian Cox, where I just spoke a whole load of nonsense. If a flat earther did what this guy is doing and said exactly what this guy is saying, people would say, oh, that's a cheap shot, that. So watch.
Asking how big the universe is seems like a silly question. I mean, it's big. Really big. How big, you might ask? Oh, I don't know. There's probably a Your Mama joke in there somewhere. But suffice it to say that it's ginormous. But ginormous isn't really a scientific term, although it should be. So, seriously now, how big is the universe? Well, the first thing you need to realize is that many people misunderstand exactly what that question is asking. We first need to distinguish between the entire universe and the universe visible from Earth.
No, you don't. The question is quite clear. How big is the universe? What do you mean? Do you mean all of the universe, or do you mean a smaller portion of the universe? If you're asking how big is the universe, you mean all the universe, not the entire universe or the visible universe. No, the question means the entire universe. There you go. No need to confuse things, but they do need to confuse things. Otherwise, they can't get away with what they're saying. You'll see.
Those are different things. So how much of the universe can we see?
Like saying, how far is India? Well, that's a bit indistinct. What really do you mean? I mean, how far is India from here? Well, are you really asking how far is India from here? Or are you really asking how far Budapest is from here? No, I'm asking how far India is from here. Anyway, let's carry on.
From our vantage point here on Earth. Well, light has a finite speed, specifically about 300,000 kilometers per second, or about 186,000 miles per second, which means that when you see...
Wait. Which means that there is nothing faster than that. No state of radiation or form of matter that is faster than that. There's a key thing that he doesn't actually say. He say the speed light very fast. Yeah, there's nothing faster than it in their own cosmology, mind.
Astronomical object, you're seeing it like it was in the past. For instance, it takes light from the sun 8 minutes to get to the Earth.
Why do you think that? Well, because we said the sun's very far away, and we say that light has a certain speed. Well, so if it's that far away, then it must be, these many minutes.
Totally knew that. But that has bigger implications. For instance, that means that there is a sphere around the Earth with a radius of the Earth-Sun distance where light takes 8 minutes to travel to us. And that...
No, it doesn't. It means there's a radius to that sphere. Not that there is a sphere. If sphere is imaginary, it's only a construct so that you can explain the radius, the distance between the Earth and the Sun, in your cosmology. But what he's saying is that there really is a sphere, so that he can use this sphere later on.
Sphere idea is true in general. There is a sphere around the Earth with a radius of a light year. If we could somehow send lots of super bright lights a light year away to surround the Earth and briefly blink them, what would happen is that the light pulse would take a year to get to the Earth, and they'd arrive at the same time. When we saw them, we'd be seeing a blink that was a year old from objects located a light year away. We can take this idea to the extreme and ask, what is the oldest thing in the universe? And that is, by definition, the moment the universe began. That happened 13.8 billion years ago. If the universe wasn't expanding, the farthest thing we would see would be a sphere centered on the Earth with a radius of 13.8 billion light years. This is what we call the visible universe. Inside that sphere, light has had time to get to us. Outside the sphere, it hasn't. We can't see anything outside that sphere.
You see? This sphere, which really is a tool for describing the radius, is now forgetting the radius and describing this sphereness. Watch, it's brilliant that the manipulation of language through the visuals is awesome, incredibly corrupting, but in terms of corrupting, it's awesomely corrupting.
Now I should caution you and point out that the numbers quoted for the visible universe are true only if the universe isn't expanding. Of course it is expanding, so the situation is a little more complicated. I made a video about how that changes things, and we might even want to take a look at it. But the bottom line is that there is a sphere centered on the Earth that is the extent of the visible universe.
That's different to the universe itself, with a Big Bang being outside of that visible universe. You see, otherwise, well, from the Earth centered in that sphere, if the Big Bang was visible 14 billion light years away, then there would be 14 billion light years in the opposite direction where things have not reached on the other side of the sphere. In the opposite direction. But he's not going to mention that, of course, because that's ridiculous.
Is that how big the entire universe is? The answer to that question is almost certainly no. The universe is bigger than we can currently see right now. And you kind of already knew that. For instance, as we look out and see the light from the beginning of the universe today, we can see out to some distance. If we look again tomorrow, we will be able to see out to that distance plus an additional light day. That's because light traveling over the course of those 24 hours will be just getting here tomorrow.
Do you see what he just did? He took a datist timeline and paired it with a linear timeline. And you can't do that. You must stick with either datist or linear. You can't just switch and swap. You see, what he's saying is, today we might look at something and not see it because it takes 14 billion light years to get here. But obviously you don't want to say that because you do see it and it did take 14 billion light years. Therefore, we're seeing something that happened 14 billion light years, but time continues. And tomorrow we'd see something that happened 14 billion and 1 day. It's literally gobbledygook.
And inexorably, day after day, we'll be able to see a larger and larger sphere of the universe. There are locations that we cannot see today because the light simply hasn't had time to get to us that we'll be able to see tomorrow. Again, this ignores the
That means, for those of you who like things like speed, that we've got faster, we're farther away from something than the light it takes from that thing to get to us. So we've travelled faster than the speed of light. Ha! We must have, otherwise we would not be so far from the thing that's emitting light. You know, light very, very fast. Speed of the solar system, very, very slow compared to the speed of light.
Due to the expansions of the universe. We'll get to that in a minute. So if the entire universe is larger than the portion we can see, how big is it? Well, to answer that question, we need to back up and be a bit more careful. Let's start with talking about the oldest and most distant thing we can see. As it happens, we can't see the moment the universe began.
So, let's talk about the oldest thing that we can see. But instead, let's talk about something that we can't see. But let's continue.
That's because the early universe was so hot that light couldn't pass through it.
The early universe, in which the Earth was, so the Earth was, it hadn't even been born. So see that little star, that little light on your screen? The Earth was a glimmer of a thought, of an idea within that there. Back there, the Earth didn't exist, so that wasn't travelling towards the Earth. No, the Earth was there. The Earth is part of that thing. And it was so hot that light couldn't, travel. It couldn't be seen. It just couldn't. Listen.
As it happens, we can't see the moment the universe began. That's because the early universe was so hot that light couldn't pass through it.
Because heat does that to light. Everybody knows, of course, that heat stops light.
You can sort of think of it like a fog. However, there was
a fog of light or a fog of non-light?
About 380,000 years after the Big Bang, when the universe cooled enough to become clear.
And that was a long time before the Earth was created.
The temperature at which that happened is about 3,000 degrees centigrade.
How do you know? Well, we just think it is. I don't know. Can you prove otherwise?
Or about 5,400 degrees Fahrenheit. Everywhere in the universe, the temperature was identical. And at 3,000 degrees, it was glowing hot.
Oh, it's good, because before that it was just black. It was just black heat. That's right. You know the Big Bang that you imagine as a flash? Stop imagining it as a flash, because it must have been just black. A big black flash.
You'd think that when we looked out with our telescopes, we'd see a glow about like what looks like when you see inside a steel mill.
Why would you? That glowing light would be, in the opposite direction. It would be a bubble, like the sphere on the Earth, in the opposite direction to where the Big Bang emanated from. You see, like, imagine you drop a pebble in a pond. You drop the pebble and the ripples go out, okay? You can't then go partway across from where you've dropped the pebble, okay, and the ripple's gone. You can't place a leaf there, way after the ripple has gone, and have that leaf look back to where you dropped the pebble to see Well, the oncoming wave, the oncoming ripple, because the oncoming ripple is way past you. You understand how time works.
But this is where the expansion of space comes in. Since that moment, the universe has been expanding and cooling and even stretching space. The upshot of that is that what once would have been viewed by the human eye as white is now no longer visible and can be only seen by radio antennae capable of detecting microwaves.
And which way are they looking when they spot these microwaves? When they detect these microwaves, are they looking towards the Big Bang? Well, no, not really. They're looking in all different directions. Oh, good Lord, really? Yes. The hell? I mean, if anything, no, it just doesn't work. Even if they were looking in the direction in which the wave was expanding away from the telescopes, they wouldn't be able to see it because it would be expanding faster than the information can make its way back, right? And the ripple has gone out already. It doesn't just hang about. But what this man is explaining, cosmologists have to take seriously. And that includes theoretical physicists. They have to take what he's saying seriously so they can answer equations based on what he's explaining.
For that reason, this oldest thing that we can actually see is called the cosmic microwave background, or CMB. And the temperature of the universe in the current day is...
And it's seen from all directions, remember. Not just from the direction where the supposed origin of the universe happened, the point where the Big Bang happened. No, don't be silly, no. From all directions.
2.7 Kelvin, or minus 270 degrees centigrade, or minus 450 degrees Fahrenheit. Pick your favorite unit. So that's the first big thing. This microwave radiation that measures that the current temperature of the universe as 2.7 Kelvin is a fossil remnant of light emitted when the universe was about 3,000 degrees.
So it's a fossil remnant. Light rushed ahead, but this radiation, it lingered. It was tardy. It was tired. It just dragged its feet. It didn't travel at the same speed of light, of course not. It was tardy, and it fell, and it died, and it kind of ossified. That means moved very slowly because, well, it was dead. It was, well, like an archaeological find of the remnant of where light had been. Listen to what he says.
That the current temperature of the universe as 2.7 Kelvin is a fossil remnant of light emitted when the universe was about 3,000 degrees. This temperature is almost the same everywhere, but we've learned that there are very small variations in the universe's temperature. These variations really are incredibly tiny. The hottest and coldest spots are only 0.01% different from the average. Our current best measurements of these variations comes from a telescope in space called Planck.
I bet.
Astronomers using the Planck Observatory have measured the entire sky, and their map of these temperature variations is what we see here. The blue spots are colder than average, and the red spots are hotter. So those temperature differences are pretty and all, but what do they have to do with the size of the universe? It turns out that these variations were...
Wait for it, because now you're going to learn something new about the universe. That's right. You're seeing, well, sound waves, but wait. Well, an image, a representation.
Caused by sound waves in the hot universe.
That's right. The hot universe? Well, it had sound, and the sound lingered. It also didn't travel at the speed of light, obviously. What medium was it traveling in? Never mind that. It was there, see?
Before it became transparent. And because we know the temperature the universe was at the time, and we've measured the total amount of matter we can see in the universe, we can calculate the wavelength of those sound waves. It's a
sound waves in space. That's right.
Complicated calculation, but it's a straightforward one. And I want to emphasize that there is no guesswork on this. We have heated matter to these temperatures, and we've measured the matter we see in the visible universe.
And then we've listened to it, and it's gone scream.
We know a great deal about the wavelength of sounds that were present. Sound in the early universe is pretty much the same as sound you used to hear me. Sound is transmitted through variations in the density of air, and you can hear a variety of frequencies.
That's right. So, you know, all that air out there in space, that's what the sound was traveling through.
In the early universe, the regions of higher and lower density, due to the sound waves, result in hotter and colder spots in the cosmic microwave background.
Now remember, this is something that's seen, supposedly, nowadays. These regions that are caused by sound to vary from hot to cold, in the emptiness of space where there's no air, is caused by sound. I know you might think that that's logically inconsistent. Never mind that, it gets better.
And given that we know the wavelength of the loudest sound in the universe before it became transparent,
hello, if it was a big bang, everyone would be deaf. I joke, don't take that seriously, Wally, I'm joking.
calculate the angular size of the most common sizes of hot and cold spots in the microwave background.
Now this gets very, very interesting. Never, I was going to say, never mind the distortion. No. Instead, I will highlight the distortion at great pains. I will go to great lengths to emphasize the distortion in what he's saying versus what he's showing.
Further, we can calculate what size is most likely, and it should be 1 degree as viewed from Earth.
So that's about twice the size of the sun. You know, if you take the sun and you say that was the radius and you kind of double that, okay, then you'd have, well, 1.04 degrees, I think. Let's pretend it was 1 degree. A circle, 1 degree. That's how big it should be. See? Simple.
Okay, so now we're getting somewhere. We have a firm prediction of the size of the hot and cold spots. This brings us closer to our question, which I remind you is the size of the universe. Now that prediction of 1 degree depends on the shape of the universe. Remember that Einstein's theory of relativity...
The retarded guy there on his t-shirt sticking his tongue out. That's right, I said retarded, and yes, I'm aware that I did show literally a retarded person earlier in this hangout. I'm not being abusive to that person, I'm being abusive to this guy here, who is not retarded. He's just deceitful.
...is that space and time can bend and morph. Space could be one of a variety of different shapes. It's hard to imagine this in the 3 dimensions that we know space really is, so we have to substitute a 2-dimensional analogy. Bear with me. A flat 2-dimensional space is like the surface of a table. Flat.
Yeah, flat. And if you were to extend it infinitely, well, those lines would converge, which means the angular resolution would get smaller and smaller. But he's going to pretend like it doesn't.
It's flat. But a 2-dimensional space could be like the surface of a globe, where, if you kept on walking, you could, in principle, end up back where you started. This is called a closed space.
Yes, could do the same on a table. In fact, I did it before in my living room. I walked in a tiny circle.
Another possibility is space could be shaped like a saddle. This is an example of what is called an open space. So those are the 3 basic possibilities of the shape of space. How does that fit into our question? It comes down to the fact that light travels in a straight line in space.
Now, you guys watching, you know that's not actually true. That's right, I'm going to show video. I'm going to show some photos that were sent to me earlier today by Donald. Very cool photos. Proving, again, I've done it before, proving that's not true. Light does not travel in these straight lines like he just explained. And that makes a complete mockery of the rest of what he explains about, well, bending of space and whatnot. But let's continue. Let's play along.
But if space is curved, then we can get fooled. Let's use the hot and cold spots in the microwave background to see what I mean. If space is flat and the distance spot in the microwave background is 1 degree wide, then we will measure the size as 1 degree. This is the simple mathematics of triangles that
That's what's the term? That's post hoc. What he's really saying is, if we measure 1 degree, then we measure 1 degree. That's right.
learned in geometry class, where straight lines travel in, well, straight lines.
But they don't in the real world. Oops!
But that behavior doesn't have to apply. Let's see why. For instance, if two ants were in flat space and they were separated by a certain distance and started walking parallel to one another in a straight line in...
Listen, this is literally taught at universities around the world in theoretical physics and cosmology. Really, listen attentively. If two ants were walking side by side with a constant distance between them,
flat space, they will always stay the same distance apart.
That's right. But it would look like a narrowing angular resolution, wouldn't it? You know, with distance.
If you do the same thing on a closed or spherical space, the two ants will eventually run into one another because straight lines in curved space are curved.
Wait a second. They would eventually run into one another here too. Or at least they would appear to, and you wouldn't be able to distinguish the difference between this flat space and the curved space.
On a closed or spherical space, the two ants will eventually run into one another because straight lines in curved space are curved. This is like line...
Straight lines in curved space, in closed space, sorry, are curved. That's right, straight lines are curved. Yes, I know you're thinking, wait, is that doublespeak? It is, it really is, but let's continue.
Longitude on a globe, where they are parallel at the equator, but intersect at the pole.
And if they go from the pole to the equator, they diverge, don't they? Oh, it's fascinating, really. Now, this is the critical point. This open space. Pay attention to that saddle space and the shape of those lines. Okay? Now, watch the ants make their way along those lines.
And the opposite is true in an open space like the saddle space. There, the two ants, initially a fixed distance apart from one another.
Wait a second, they're not staying to those lines. They're just moving across. I mean, you could do this on the curved space and the closed space too. You could just divert them if you want, like you're doing in this image. Can you see how the one to the right is not actually sticking to that line?
Walking in straight lines will eventually diverge and get farther apart.
Well, do you see a problem here? Yes, it's because it's a crock of shit.
That's just curved space for you. So this has constant...
I'm going to play that again. It's brilliant.
And the opposite is...
Remember, until now, the exercise with the ants has not been to keep them a constant distance from each other. It has been to keep them on lines. First on the open flat space, then on the closed curved space, and now on this open saddle space, to keep them on lines. That's why they converged according to the longitudes on a sphere, because they were sticking to those lines. But with this example, suddenly, oh no, now we're talking something different. Now we're talking not sticking to lines.
True in an open space like the saddle space. There, the two ants, initially a fixed distance apart from one another and walking in straight lines, will eventually diverge and get farther apart. That's just curved space for you. So this has consequences when measuring.
Now, when people like this guy, or Wolfie, pay attention to this. When somebody starts a sentence with so, it's implying that what's being said is a conclusion of some type. This and this and this. So, this and this. The guy has just used it. I'm going to play it again. This little
Will
linguistic
eventually
trick.
diverge and get farther apart. That's just curved space for you. So this has consequences.
So, forget the fact that what he just said is complete and utter bullshit. No, the conclusion is so.
When measuring the apparent size of these distant spots in the microwave background. If space is flat, the line that crosses the spot you're looking at and the two lines that go from the edges of the spot to your telescope form a common triangle.
Except you can't see the straight lines. You can't. You can only see the angular resolution.
But in an open or closed curved space, the triangles are distorted.
But you wouldn't know, because all you're receiving is the angular resolution.
Let me be more specific, because this is super important. In a closed or spherical space, what one would expect to be a straight line is curved in a specific way. The crucial effect is that the angle of the triangle near your eye is bigger than if space wasn't curved.
But you wouldn't know unless you could trace the curvature of those lines. You cannot trace the curvature of those lines, therefore you have no way of determining, is the thing 1 degree at distance A, or is the thing 1 degree at distance B?
Opposite is true for an open or hyperbolic space. Here, the curvature is in the opposite direction. We see that the angle of the triangle near your eye is smaller than if space isn't curved. Now, the telescope can't see the whole path traveled by the light. All it sees is the angle of the light coming into your eye or the telescope, with a closed or spherical space being bigger than expected, and the angle seen in the open or saddle-shaped space being smaller.
But wait, what causes this expectation? Theory. Oh, I see. So if your theory says should be this, but it isn't this, then it means this other effect is happening. Right. That's interesting. Your theory, which is supposed to be based on observation, dictates the observation. That's interesting. Isn't that putting the, well, is it the cart before the horse?
And if we apply this to the spots in the microwave background, this means that a spot that is 1 degree wide in flat space will be different in a curved space. So this is a perfect way to...
So this means if we receive this, and if we wanted to say, but it's really this other thing, then we could. He doesn't, don't worry, he doesn't. But it does mean that.
Test whether space is flat or curved. In a flat space, the dominant size of the spots should be 1 degree. If space is curved and closed, the spots should look bigger. If space is curved and open, the spots should look smaller. So,
unless light is arriving through a different avenue, along different paths, that you hadn't expected. You see?
did Planck and other experiments find? A drum roll, please, maestro. The measurements found the size of the spots is 1 degree. From that, we conclude that space is flat.
That's right, but never mind that, because we just saw it's all based on a crock of shit. But let's continue. And it is true, by the way. Theoretical physicists and cosmologists explain that space is flat, that we live in a flat universe. They really do, including Michio Kaku. Those guys, they really do explain that. They then say, oh, but it means this other thing, but they explain that.
Or can we? Well, yeah, sort of. But that's an incautious statement. Physics is an experimental science. When we say that the Earth is flat, the measurement is consistent with being flat.
I'm trying to pause it.
But that also means that the measurement is consistent with
Pause. You're hearing him say what you're hearing him say, by the way. I'm trying to pause and now. Right. Pause. Okay. I'm going to go back and play it again.
Space is flat. Or can we? Well, yeah, sort of. But that's an incautious statement. Physics is an experimental science. When we say that the Earth is flat, what we mean is that the measurement is consistent with being flat. But that also means that the measurement is consistent with a tiny bit of curvature. For example, if we're at the beach on the ocean and look at the horizon, it surely looks flat. But in spite of the claims of some people, the Earth is most certainly not flat.
Do you have any evidence for that? No, we don't really. All of the evidence we have, including the observations, says flat. I'm going to play that again so that it can be fully grasped by people, even though I maintain that what he's saying is a crock of shit. They have to stay within certain parameters within that bullshit. Otherwise, some of their own PhD students would call them out on it. So they have to say certain elements that are true. So I'm going back to where he explains that space is flat. And that when they say that the Earth is flat, they mean that it just appears according to measurement.
So what did Planck and other experiments find? A drum roll, please, maestro. The measurements found the size of the spots is 1 degree. From that, we conclude that space is flat. Or can we? Well, yeah, sort of. But that's an incautious statement. Physics is an experimental science. When we say that the Earth is flat, what we mean...
Remember, he was talking about space and the hotspots caused by sound back in the history of time being an indices of that space being flat. Now he's switched from space being looked at from an object in space, looking out into space, determining that space is flat. He has now quickly shifted to, so what we mean when we say the Earth is flat, not the measurements of space resulted in a flat conclusion. No, the Earth. Watch, I'm going to play it again.
Well, yeah, sort of. But that's an incautious statement. Physics is an experimental science. When we say that the Earth is flat...
When we say that the Earth's flat, why are you saying the Earth is flat? You haven't said the Earth is flat until now. You've not been talking about the Earth being flat. You've been talking about vectors in space.
What we mean is that the measurement is consistent with being flat. But that also means that the measurement is consistent with a tiny bit of curvature. For example, if we're at the beach on the ocean and look at the horizon, it surely looks flat. But in spite of the claims of some people, the Earth is most certainly not flat.
Despite their claims. And here's the evidence why it's not flat. Oh no, sorry, that's a topic for a different video.
It's a sphere.
It's a sphere. Yeah, that's right. We say it's a sphere, so it's a sphere. That's right. Jesus is Lord. I mean, praise Allah. Whatever we say is what it is, because we say it.
So you have to keep this in mind. What appears to be flat can, indeed, be curved. And when we measure the Earth, we can only say that it appears to be flat.
Oh. It's round. In imagination, it's round. It appears to be flat. Measurement says it's flat. We could say there's a tiny element of curvature that we've added post hoc, not in the earlier descriptions of the flat space, closed space, and open space. Not there. We didn't talk about curvature being possible there. Now we're saying curvature. Now, results saying flat could mean tiny amount of curvature. That's right.
And that's true of space as well. Space appears to be flat. If, and I repeat, if space is flat, then the universe is infinite in extent. Our visible universe is just a small bubble in an infinite sea.
Oh, it's in a dome. I can see some flat earthers there having a little jissy fit. No, it's not a dome. We only have a limit to what we can see. We also have a limit to what we can reach. That's it. Now, just so you understand, you could spend all your life in a sedentary position and just turn every day, just turn on your backside and look in different directions, and your experience of the world would show you, well, a circle or a dome around you. However, you could be the complete opposite to that person. Not a sedentary individual, but a straight line moving individual. What would you have then? Would you have a circle for your life experience? No, you would not, would you? You would have a line for your experience. How wide is that line? Depends how much time you spend looking left and right. If you were looking only ahead, then it would be a narrower line.
Similarly, if space is shaped like a saddle, what scientists call a hyperbolic or open space, space is also infinite.
So, flat space, infinite. Hyperbolic space, infinite.
If space is closed and shaped like a sphere, but so big that it looks flat, like the Earth can look flat, well, in that case, space is not infinite, it has a finite size. So now we're getting somewhere. If the universe is closed, how big is it?
Now, until now, the evidence has said it is not closed. But now let's consider it as if it was closed.
Well, if you do a careful analysis using the maximum possible curvature allowed by the best measurements, you find that the universe can be no smaller than 250 times bigger than the visible universe.
You heard that right. According to this gentleman, the visible universe can let us see all the way back the radius that the Earth has travelled from the point of the Big Bang and travelled here over a period of 14 billion years. We can see that far. Listen to how big he says the universe is, bearing in mind all of the data says flat and infinite, but now we're choosing to say, well, it could be spherical. Although the evidence says flat, it could be spherical, right? Can't we just add a tiny little bit of curvature?
Curvature allowed by the best measurements, you find that the universe can be no smaller than 250 times bigger than the visible universe.
250 times bigger than the radius. So let me just make a note. 250 times. Wonderful.
So that's your answer. I mean, we've always kind of thought that the universe is big, but now we can hang a number on that. The visible universe, meaning the part of the universe that we can see using our instruments, is a sphere centered on the Earth and, taking into account the effects of expansion, with a diameter of 92 billion light years. However...
What? It can't be. It can't be a diameter of 92 billion light years. Because, well, the distance from the Big Bang, and the Big Bang is the farthest thing we can see, we can't see farther than that, and we can't really see it because it's not really there. It's, well, 14 billion, 14.5 apparently. but 14.6. No. 250 times more. That's 92 billion. Oh, wait, what? Really? That's 14 billion times 250. That equals 92. What common core math is this?
The entire universe, including the parts that we can't see, is at least 250 times wider than that. And
oh, right, wait. We can't see just 14 billion years. No, we can see 92 billion years. And this entire universe that we can't see at all is 150 times more than 92 billion. I'm going to play it again because there's a little bit of word salady, wasn't it?
The universe that we can see using our instruments is a sphere centered on the Earth and taking into account the effects of expansion with a diameter of 92 billion light years.
So diameter, so half of that would be radius. That would be, well, if you were looking just in the direction of the Big Bang, you'd have the radius of the Earth's position relative to the location of the Big Bang. The diameter, well, is twice the radius, obviously. Okay, great. 28 billion. Oh, no, sorry, 92. That's interesting. I thought the diameter was twice the radius.
However, the entire universe, including the parts that we can't see, is at least 250 times wider than that. And the universe could indeed be infinite in size. We've come a long way from simple speculation about the universe. Seemingly intractable questions are now getting answers, and that is your fascinating fact for the day.
Really? We're getting answers where they just add factors. You know, like, can we add a tiny bit of curvature? Sure. Okie doke. I hope you're enjoying this. I thoroughly enjoyed it. I passed it to Sasha. She left a comment. Sasha, your comment disappeared, by the way. It's not there. Can't find it. So I'm now going to play the next video. If the universe is only 14 billion years old, how can it be 92 billion light years wide? But wait, no, silly. 92 billion light years is visible, apparently, right? And its actual size is 250 times more. We just heard him say it. That's right. Well, we're going to hear him say something different. Hope you enjoy this tasty snack, this delicious food for thought. This wonderful brainwashing. Come on. Oh, it's now going to do that. Moving forward faster than...
Things that are far away. We're looking at things that existed.
Okay, so now we're going to go back to the beginning. I don't know why it does this sometimes, but hey.
When we look out into space, we are not only looking at things that are far away, we're looking at things that existed in the past. For instance, the sun is about 93 million miles away, and it takes light about 8 minutes to get here. Thus, when we sit down in the morning with some toast and our first cup...
I just needed to pause. Okay. Light years and years have a shared criterion. That being years. In 14 billion years, something can only be 14 billion years old. That means only 14 billion years have happened. That means only 14 billion light years can happen in 14 billion years. Come on. Oi, come on, system. And again, what you're seeing is taught in university. Come on, system, start responding, please.
Coffee for the day and look at the sun, we're seeing it not as it is now.
Okay, now it might be fine.
8 minutes to get here.
Right, so we can see through time. That's right, I'm going to rewind. You might think this is an episode of The Simpsons, you know, but no. It's a real world. You see, we see back in time. Oh, that's interesting. We can see to 8 minutes ago. That's interesting. Why don't we look a little further back and look at 2 weeks ago and see where the Earth was?
We're looking at things that existed in the past. For instance, the sun is about 93 million miles away, and it takes light about 8 minutes to get here. Thus, when we sit down in the morning with some toast and our first cup of coffee for the day and look at the sun, we're seeing it not as it is now, but as it was when we put the bread in the toaster.
Right. Okay, so if we looked a little bit farther back in the corkscrew of the solar system's path through space, why don't we just look a little bit farther back? You know, not to when we were putting the toast in the toaster, but when we were driving around 2 weeks ago. Why don't we do that?
Time and space are inextricably intertwined when we talk about how far away things are. This is especially true when we talk about large-scale structures of the universe. We even have a distance scale called a light year, which is the distance that light travels in a year.
Wait, the distance light travels in a year. That's right. So how far can it travel in 14 billion years? Would it be 14 billion light years? No, 92 times 250.
In more familiar terms, a light year is 9.5 trillion kilometers, or just shy of 6 trillion miles. We use the unit light year because nothing travels faster than light. It's very convenient.
Now, remember that. Nothing travels faster. We know it's a crock of shit, okay, but we're going to play along. Nothing travels faster than light. First, the universe was just black. Then it exploded blackly, okay, because there was no light. It couldn't make its way through. Too hot. Expanding at the speed of light. For how long? Well, 14 billion years. Oh, okay. So there you go. That's the answer. 14 billion light years. No, don't be silly. It's faster than that.
It's most convenient when we talk about the size of the universe. Astronomers have determined the age of the universe very precisely.
Really? 13.7 billion. Oh, really? Have they really? Or did they just make that up?
13.7 billion years old. Exactly how we know this is perhaps the subject of another video, but...
Now, remember, folks, I'm giving you this little delicious snack for thought, just so you can play with it and use it for processing the world around you, how people speak to you, about you, to each other, how the news speaks to you, for those of you who pay attention to the news. He just said exactly how we know this. I'm going to play it again.
Have determined the age of the universe very precisely.
They have determined. That means it's a pretty solid conclusion.
13.7 billion years old. Exactly how we know this is perhaps the subject of...
Exactly how we know this. Not exactly why we think this, which will be the language of the honest scientist. No, instead, exactly how we know this. You don't know this, Dim Dim. You think the sun is a big plasma ball of nuclear fusion out there in space.
Other video, but for the moment, let's take that number as a given.
This is another thing they do. Take things as a given. Somebody concluded this, and they said that it's all totally legit, nicely tied, no loose ends, everything solid. So we can take it as a given. Let's continue.
Two, we can ask a very simple question. How big is the visible universe?
I'm going to go back so we can hear. I was going to call this Hangout, instead of the delicious snack, I was going to call it the God of If. That's what I was going to call it.
Video, but for the moment, let's take that number as a given. If we do,
They've almost made the if into the start of the next word. If we do. Oh, I should have called this if we do. I'm going to start using that. If we do.
We can ask a very simple question. How big is the visible universe?
Very good. Now, the question is, if the universe is only 14 billion years old, how can it be 92 billion light years wide? It can't. You're right with the question. But if we think of it this other way, now we're going to look at how big the visible universe is. Now, we covered some of this in the previous video, but we're going to go over it because it's great. First, we have to figure out how much we can see, right? So let's do that.
There are lots of tricky ways to think about that, but let's start with perhaps the most obvious. We can't see the universe before it began because, well, that's what beginning means.
But wait, I thought we could see back in time. Can't we see? We can see back in time, like 8 minutes. You know, we're seeing the sun when we were putting the toaster in. But we were putting the toaster in 8 minutes ago. We're eating it right now. Why don't we look a bit farther back to like before the, you know, like the 8 minutes that we see like naturally? Can't we just do it a bit more? Oh.
When the universe began, it was filled with light, which then traveled through the cosmos.
Remember, this light that he just said, in the earlier one, he said, but it wasn't light because it was too hot. So it must have been a black bang. That's right, the Big Bang that you've been imagining in your brain being blackness and then a big flash of light. Wrong. It's blackness and then a big flash of blackness in that black. Yeah, because it was too hot for light to make its way through. You heard this gentleman saying it, and he's a cosmologist. So, now he said, oh, no, it was light. Like, no, if light couldn't exist because it was too hot, then it wasn't light. So I'm going to go back.
Began because, well, that's what beginning means. When the universe began, it was filled with light, which then traveled through the cosmos.
Oh, I think maybe some people, some pedants will say, he's skipping over the first 300 million years or whatever until they reach that point of temperature where light could happen. And he's referring to that. Well, that's not when it began. That's sometime after it began. And he just said when the universe began. So you're wrong. Sit down.
And if the universe began 13.7 billion years ago,
if the universe began,
we're just now seeing it arrive.
And we're just now seeing it arrive. That's right. You remember when I said before, you drop a pebble in the pond. And the time and sequence and how reality works is like this. You let go of pebble. Pebble falls because of gravity. Pebble falls down, hits the surface of the water, goes through the surface of the water, and then we forget about the pebble because now we're looking at the surface of the water. A little drop makes its way up and flies up into the air and then goes back down. By the way, time it goes back down, the ripples have already started spreading. That's the sequence. Now, that was the beginning at the speed of light. At some point after that, so within that circle that's expanding, after, like within the circle, so picture it as a hula hoop that's getting bigger and bigger, okay? So the hula hoop is now A-size. You place a leaf inside that hula hoop, okay? somehow, looking towards the beginning, towards the center where the pebble dropped, you can see the ring that's actually on the other side of you. That's right, because the ring is arriving at you, not ahead of you. That's right, because we can reverse language and the meaning of words like time and motion when we're talking about the heliocentric model.
It had to have traveled 13.7 billion light years before it hit Earth.
Did you hear that? So Earth must have been there just hanging about for all these 13.7 billion years, whilst the light from the Big Bang, that period after the black flash, okay, whilst it made its way to the Earth. That's right.
And to make that point solid, astronomers can actually see light from shortly after the universe began.
That's right, because light is hanging out. It's not moving at the speed of light. No, it's just hanging out. That's why it's arriving, because it's just hanging out, dude.
It's called the cosmic microwave background radiation, and it is the oldest thing we've ever seen. It is hitting the Earth from every...
I don't know about that. I've seen some pretty old shoes. But let's continue.
...direction, and it is, to all intents and purposes, a photograph of the birth of the universe 13.7 billion years ago.
That's right. That's right. You know how you can take a photograph of your great-great-great-great-great-great-great-grandchildren? Yeah. You can take a photograph now. You can take a photograph of your great-great-great-great-great-great-grandchildren. You might say, no, you can't. Why not? Because it haven't happened yet. What do you mean not happened yet? Well, it's just not here in time. All right. So would that be like taking a photograph now of your great-great-great-great-great-great-great-great-grandfather? No, why not? Because it went. That your great-great-great-great-great-great-great-great-great-grandfather is no longer around. You can't take a photo. That time came and went. They're saying we're taking a photo of something that came and went. That's right, folks. This is cosmology for the globe retardeds.
Accordingly, it would be reasonable to say that the visible universe consists of a sphere centered on the Earth with a radius of 13.7 billion light years.
That's right. See, the radius I had was describing before. I had said 14 billion. I'm rounding up.
Done. Except that this is completely wrong. That's one of the sneaky things about science.
That's one of the sneaky things about science. We can tell you things that are completely wrong, and depending on how we end the sentence, you'll either go away thinking it's true because we told you, or you think, oh, you little trickster, you tricked me. You know, like when that guy said, oh, we sent a thing up to an asteroid, you know, to see what it was like, and yeah, if you were on that asteroid, you could jump over mountains like Superman, and we heard it sound, but we didn't really. We just translated radiation into what sound it might make if it could make sound.
Fool you if you think too fast. Sometimes you have to slow down and mull things over. And if you think about it for a moment, you'll realize that this way of thinking assumes that the universe is static.
No, it doesn't. It says the universe would have a radius of 13.7 billion light years right now. In another 13.7 light years, it would be, well, twice the radius. That's not static, that would be growing.
And, at least on average, distances between objects aren't changing. But we know this isn't true. To begin with, the Big Bang happened.
Oh, there's some misleading footage. Should be a great big black flash. In fact, I'm going to go back.
At least on average, distances between objects aren't changing. But we know this isn't true.
Hey, what's that bright thing in the middle of the screen? And it wouldn't be the very beginning of the Big Bang, would it? Because that should be black. And then followed by, oh, what the heck are those stars? Take those off too. And then the next sequence should be a great big black flash in that blackness.
To begin with, the Big Bang happened.
Oh, Okay.
The universe is expanding, and it used to be expanding much faster than it is now.
Yes, it was expanding at the speed of light. Not faster. Not fast enough to be 92 times 250 billion light years wide. No, silly.
That means that the simple answer isn't good enough. I don't want to get too deeply into the details of the Big Bang, but it boils down to
The famous words of the charlatan. I don't really want to tell you the ingredients of my snake oil, secret formula. Rest assured, it will cure all your ailments. I don't want to get too deeply into the details of the Big Bang. You can't, you moron. It's a fantasy and it's logically impossible. But let's continue.
the idea that the universe was once smaller and hotter and has been expanding since the beginning. I made a video about it if you want more. And that expansion is key to understanding what is going on here. We start by imagining what the universe looked like when this...
So, go into your imagination, tell Santa Claus to get off you, and then just look out of the window in Santa Claus' home. And oh, Santa's wife is making a lovely cocoa. Now continue with your imagination and think this.
Microwave background radiation was emitted. It was hot everywhere. No place was special. Well, I guess one was, kind of. And that place is the current location of Earth.
That's right. So, back when everything was really hot, ubiquitously hot, okay, there was a place in space that hadn't been reached yet, okay, because it wasn't reached for some, well, 9 billion years. Yeah, so 9 billion years before the Earth was there was a special place in space called where the Earth will be in 9 billion years.
But at that moment, it looked like everywhere else. Now, there was a sphere centered around that point and at that time.
Yes. You know that point and that time that nothing had reached into, the Big Bang that was expanding? Well, it hadn't reached there, so it was like making up the space as it went along. Well, at the region that it hadn't quite reached to make up the space that it was making up as it went along, it kind of projected, like thinking about next week, it projected thinking about 9 billion years down the road and said, and there will be a sphere. And it was so. There was a sphere there ahead in the future of the space universe.
That sphere is the origin of the cosmic microwave background arriving at the Earth now.
That sphere is the origin of the cosmic background radiation that's arriving at the Earth. The origin of the cosmic background radiation arriving at the Earth that we said earlier was the beginning of the universe wasn't really the beginning of the universe. It was this 9 billion year younger sphere around the Earth.
That radiation moved toward the Earth at the speed of light, and it took 13.7 billion years to get here.
Oh, interesting. And from all directions. Forget the figures that he's saying, he's just making them up.
If we look at a sphere smaller than that special sphere, that light has already passed the Earth, and we can't see it. Light from a bigger sphere isn't here yet, so we don't...
See the trick? So, because he's showing images of this sphere around the Earth, sending light towards the center, and people can go, right, okay, so light moving reaches Earth, and wait, wouldn't it have gone past? No, because we've made the sphere bigger now. It hasn't reached yet. Like, no, moron, it would already have gone past. It would just have gone past a bigger limit too.
Yet, either. When this light was emitted shortly after the Big Bang, this sphere's radius was about 42 million, that's with an M, light years away. Naively, you'd expect that this light would have taken 42 million years to get here.
But you'd be naive to think that, because I said, naively, you would think it had taken that long to get here.
The took 13.7 billion, and that's with a B, years to travel to Earth.
That's right. So, it took 4 million, but 13.7 billion. That's right. I'm going to say it and then steeple my hands together and purse my lips. And you better not question me or I'll fell you, bitch.
And the reason that it took...
I'm going back so I can play that again.
Shortly after the Big Bang, this sphere's radius was about 42 million, that's with an M, light years away.
Now, shortly after the Big Bang, the imaginary sphere in the future... So there was no sphere there because there was no space. It hadn't been made by the Big Bang, forging its way ahead, inventing space into which to fall. Okay, so farther away from the limits, there was this place where there was this, well, there wasn't anything, obviously, but in the future there would be a sphere, and that sphere, 42 million light years. That's right, the radius of that sphere in space that didn't quite exist yet, 14 million light years. We say that because that way, you know, mathematics.
Naively, you'd expect that this light would have taken 42 million years to get here, but it took 13.7 billion, and that's with a B, years to travel to Earth.
No, it didn't. You have to at least take away the 4 million, 4.7, but never mind. Let's not get pedantic.
And the reason that it took so long is that space was and is expanding.
See, it was and is expanding. So, when this sphere around the future Earth was concocted in the thought of the expanding universe, it didn't exist yet because it hadn't reached, because the universe was expanding, it hadn't reached yet. Like a leaf outside of the expanding ring, you know, the pebble in the pond, and there's the ripples emanating out. Okay, well, before we're playing with a leaf inside the ring to say, you know, to show some of the bullshit that they're talking about. Now we're talking about a leaf farther out, and the ring hasn't reached yet. Now that leaf, it's not a real place, okay? It's an imaginary sphere around the imaginary future Earth. That's right.
Now, if you think about that, it means that space between that sphere and the location of the Earth had to be expanding pretty fast. Otherwise, the light would have passed by the Earth long ago. I mean, it was only 42 million light years, and it's been nearly 14 billion years. So that sphere from which the microwaves were originally emitted also grew in size.
See, the microwaves, you might think of the word emit as, especially with radiation, and we're talking microwave background radiation. Radiation is an outward motion, not an inward motion. Okay? An outward motion. Well, the sphere was emanating inwardly, which first is the opposite of emanating, and it's inwardly, even though, well, the source for the direction of radiation must have a direction, you know, as in direction for radiation, but somehow it was also happening from the entirely opposite direction too. That's right. Some of you might be saying, that's not, I mean, not only is that logically inconsistent, that's logically impossible. And you'll be right. But let's continue.
And, in the simplest calculation, that sphere would now be 41 billion, that's with a B, light years away.
So, you know that sphere that was imaginary, that was projected into the future of where the universe was expanding into, okay, that sphere ahead in the future where space had not even been invented yet, because, you know, nothing had reached there yet, apart from the expanding universe's imagination. That sphere that's invented, 41 billion light years. That's right, because you see, the adolescent expanding universe, you know, it was 9 billion years old, and he thought, wait a second, I know, why don't I invent a place in the future and say that that place is even bigger than me? That's right.
However, it turns out that the simplest calculation isn't quite right.
So, he's just told you, naively you'd think this. Obviously you'd be a retard to think that, so don't. Now there's this equation, and it shows this, but obviously that's wrong. This is what this dude is doing. I'm going to go back and show you.
Expanding pretty fast. Otherwise, the light would have passed by the Earth long ago. I mean,
that's right. You know, if light functioned and time and motion and speed were things, you know, that happened, then it would have way gone by. There's no big chance of looking back and seeing it. What kind of weirdness is that? If like driving away really quickly from a stoplight and looking ahead of where you're going to reach that stoplight. I mean, it's just stupid.
Only 42 million light years, and it's been nearly 14 billion years. So that sphere from which the microwaves were originally emitted also grew in size. And, in the simplest calculation, that sphere would now be 41 billion, that's with a B, light years away. However, it turns out that the simplest calculation isn't quite right. You see, about 5 billion years ago, an energy field that we call dark energy became important.
Oh.
Dark energy is a repulsive form of gravity, which means that the
Wait a minute. Wait. A repulsive form of gravity. So there's gravity, pulls, and there's something that pushes. A repulsive. Gonna go back. That's right. You're hearing it here. You've probably heard it elsewhere, but yeah, you're hearing it here. Yeah, you see, we needed some explanation for things that didn't make any sense even in our cockamamie world, so we invented a thing.
About 5 billion years ago, an energy field that we call dark energy became important. Dark energy is a repulsive...
What do you mean by field? Oh God, don't... Get out!
...of gravity, which means that the expansion of the universe isn't slowing down, it's accelerating. That, of course, that means after 9 billion years of the expansion...
So, you know how it was accelerating at the speed of light? Well, guess what? It's going to accelerate from that speed. Do you understand what, terminal velocity might mean? Well, you might consider light to be this thing, this terminal velocity concept, this no faster than idea. But dark matter comes along and suddenly, yes, faster than.
Space slowing down, it's now speeding up.
Mm-hmm.
When you take into account the effect of dark energy, that radius of the sphere from which the microwaves were emitted has grown from 42 million with an M light years to 46 billion with a B light years.
That's right. That's the radius of the sphere, where the sphere, that's imaginary, is emitting inwardly. It's imbibing radiation. That's right, from all directions. Not just from the direction that the radiation came from. No, don't be silly, from all directions. Yes, I know that you might think that a source point in space might have, well, an index of direction, do you know, from where energy could come? Well, we're turning that into 360. That's right, by 360. That's right. It's going from those directions, all of the directions. That's where it's coming from. Which way is the center of the universe? Wherever you point your finger, that way.
And this highlights the confusion that arises from expanding space. We see the light from shortly after the Big Bang. It was emitted a short distance away, and now the location from which it was emitted is now about 1,100 times farther than it was.
Now remember the speed of light being constant and years and light years? Well, now, way, way faster than that. That's right.
Further, when we see it as it was then and not as it is now.
How? Oh yes, because it's that fossilized version of it. Yeah, it's like its footprints.
Indeed. Remember that when the light was emitted,
the
conditions at the location of the sphere...
Pause. Because I have to point this thing out. PMAS, are you paying attention? He just said the word Indeed. Ah, you better not question that because he just said indeed. It's the same as it turns out, we now know, and so, indeed. So, listen.
And not as it is now. Indeed, remember that when the light was emitted, the conditions at the location of the sphere were the same as here on Earth.
So, the conditions of the sphere that the light would ultimately reach, because that sphere was in the future of that expanding universe, the conditions of that sphere being not having an Earth inside and not having any radiation emitted from the outer hull of that sphere towards the center. So those conditions of entirely different to how the Earth is now were identical to how the conditions are now. Gonna play it again.
Indeed, remember that when the light was emitted, the conditions at the location of the sphere were the same as here on Earth.
That's right. They were the same. You know those very different conditions? They were the same.
But the conditions here have changed.
So they weren't the same because they've changed. Good Lord, will you? Is it black or red? Are you going to bet? Come on, we want to spin the wheel on this roulette.
Instead of a bath of energy, we now have stars and galaxies.
I'm going to go back so you can hear that little bit of word salad. Yeah, so the imaginary Earth sphere in the future, those conditions where there wasn't an Earth or anything, okay, they were the same as the conditions on the Earth, except the conditions of the Earth have changed. That's right. Yes, let me smack you.
Location of the sphere were the same as here on Earth. But the conditions here have changed.
Where would here be? Would that be here on Earth? Yes, that's right.
A bath of energy, we now have stars and galaxies. That's also true on that sphere.
Except that, so if the conditions have changed by the fact or by virtue of us having stars and galaxies, and he just said, and those conditions were the same for that sphere too, well, that would mean that that sphere also had stars and galaxies, but it didn't. Did it have stars and galaxies? No, it didn't. So I'm going to play it back.
Indeed, remember that when the light was emitted, the conditions at the location of the sphere were the same as here on Earth. But the conditions here have changed. Instead of a bath of energy, we now have stars and galaxies. That's also true on that sphere. So, if we could somehow see...
You see? The conditions were the same, but they've changed. They've changed because there are now stars and galaxies. And it turns out that there were stars and galaxies back then too. So it hasn't changed. See?
46 billion light years away, presumably there are also stars and galaxies. But we don't see them there because light from objects that are currently that far away hasn't had time to reach us yet. In fact, and this is a mind blower, we'll never see those stars and galaxies.
Oh.
After all, they are moving away from us very fast and space is still expanding. We saw that the location when the universe was young, but we can't see them now. It gets weirder. Currently, there is a sphere around...
Wait, I'm going to rewind. Because there were some doozies in there.
But we don't see them there because light from objects that are currently that far away hasn't had time to reach us yet.
What? How long does it need to reach us? It's had, well, 14 billion years, plus 92 billion years, plus 41, was it, billion years? Times 250 billion years. And all of these years are also light years. How long does it need? Can't you just change the equation and say it's reaching here now? You could if you wanted to, but obviously you're not going to because you're a charlatan. So let's continue.
In fact, and this is a...
Oh, there's another doozy. In fact. You better not question that because he just said, in fact.
Mind blower, we'll never see those stars and galaxies.
Then how do you know they'll ever happen? Well, we're projecting that they'll happen. Oh, okay, that's interesting.
After all, they are moving away from us very fast and space is still expanding.
But they're not moving away from us at the speed of light. But let's continue.
We saw that the location when the universe was young, but we can't see them now.
So, remember the original radius of 14 billion years? Meaning 14 billion light years too, okay, or 13.7 to be exact. We could see that back then, okay, but there's other equations of things in other directions and other hypothetical Earth spheres in space, and we can't see that. That's right. You can't see next week. Don't be silly.
It gets weirder. Currently, there is a sphere around the Earth with a radius of about 15 billion light years.
That's right. That's a real sphere, except it's a dotted line. It's a sphere of dotted dashes. Obviously, that's just a circle, but you're supposed to think it's a bubble. Okay, so that bubble, yes, 15 billion light years. That's right. Yeah, because we just said so. But guess what? There's another one, okay? And it's 150 billion light years. And there's another one. There's 150 million billion light years. And there's another one. And you can just do that ad nauseum.
Objects that are now outside that sphere at this moment will never see as they look now, no matter how long we wait.
That wasn't mind-blowing. That's a bit retarded. So saying, hey, you know you can't see this sandwich that you just ate? Yeah, because I just ate it. You know, what's bamboozling about that? You just said, and there's things you can't see because you can't see them. Oh, okay, that's interesting. That's right. And there's even more things that you can't see because you can't see them. And you know why? Because you can't see them. And get this, there are other things that you can't see because you can't see them. And you know why you can't see them? Because you can't see them. Yeah, bet you didn't think that.
I'll repeat that so it can sink in.
Yes, so let it sink in.
We can currently see objects 46 billion light years away.
Even though 46 billion light years have not happened. Remember, 46 billion light years have not happened. That's right, that's the part that he's neglecting to highlight. See, beginning of the universe, 13.7 billion light years. Sorry, years. 13.7 billion years. What does that mean? That means that according to their theory, time has been ticking for 13.7 billion years. That's right, but we're going to pretend like there's even a different time. That's right. Going to play it again.
Look now, no matter how long we wait. I'll repeat that so it can sink in. We can currently see objects 46 billion light years away.
That's according to the theory of time, and he means 13.7, okay? 13.7 billion light years away, and that's limited by the 13.7 billion years of time. But
we see them as they were in the distant past.
Right, okay. Like seeing your great-great-great-great-grandfather. That's right, just watching him doing some laundry.
Any objects that are currently within 15 billion light years, we will be able to see as they are now, although we'll have to wait a long, long time for that light to get to us.
Yeah, whatever.
And because of the expansion, it gets worse.
Right.
It means that we constantly lose stars that we can see. Indeed, we lose about 20,000 stars per second. So there are stars that emitted photons at this moment that we will eventually see, but the photons that they emitted at this slightly later moment that we'll never see.
No. It just completely shit on what he was saying earlier about the 8 minutes. No, we just have to wait a moment and we'll see them in a moment, won't we, dumbass? Remember the very start of this, he said, you know the sun, 8 minutes, light. When you're having your breakfast, a piece of toast or a cup of coffee, well really, you're seeing the sun 8 minutes ago. That's right, when you were making your toast. So, if something is emitting light and you're seeing it now, and it emits some light at some point later, all you have to do is wait a little longer and then you see it. Look at him, dumbass. I'm going to play it again. In fact, I'm going to play a longer portion.
At this moment, we'll never see as they look now, no matter how long we wait. I'll repeat that. So
he's saying, look, there are things whose light has never reached here and will not reach here while there is anyone here to see them. Okay? These are completely imaginary things, obviously. So, because nobody will see them, nobody, wait for it, will see them. That's fascinating.
Sink in. We can currently see objects 46 billion light years away.
Wait, even though that light from 46 billion light years would be, well, in the other direction, way past us, remember that bit? But no, let's pretend that that's not true.
But we see them as they were in the distant past.
That's right. We're seeing their footprints in the sand, because Jesus was carrying them. You know, the footprints in the sand. You know, the footprints all the way back to the beginning of the universe. The footprints of the universe as it grew, and now we look back and we can see the footprints. But those footprints are travelling at the speed of light. Oh, that's interesting.
And any objects that are currently within 15 billion light years, we will be able to see as they are now, although we'll have to wait a long, long time for that.
Not really. It could be they could be within these 15 billion light years. In 3 seconds' time, in which case, 2, 3. Aha! See then, just saw it now. Dumbass. Doesn't mean because it's 15 billion, within 15 billion, it's at the farthest reach. It's within. You just said within. Oh my God, this is so word salady. It's like Patricia Steer.
Like to get to.
I mean, the imposter who played itself off as that.
And because of the expansion, it gets worse. It means that we constantly lose stars that we can see.
Wait, that means, first, they haven't got a clue what stars are, and sometimes they're looking and go, oh, I thought there was a star there before, now there isn't. Oh, that's interesting.
We lose about 20,000 stars per second. So there are stars.
Don't worry, they're replenished by about 20,000 stars per second, too. Give or take. Depends who's looking.
The emitted photons at this moment that we will eventually see, but the photons that they emitted at this slightly later moment that we'll never see. One day, the expansion of the universe will make it so that almost all of the galaxies we see in our telescopes today, which I remind you now we're seeing as they were in the distant past, will slip from our view. We will one day only be able to see galaxies from our local group, meaning the Milky Way, Andromeda, and a few dozen minor galaxies in the vicinity.
Mm-hmm.
So that's the answer to the question. Our visible universe has a radius of about 46 billion light years, even though it's only 13.7 billion years old.
That's right. So you heard years in light years and years in years old, and those years are the same periods of time. Yeah? So, you know how you might be 38, but really you're also 152,000 million years old? Yeah, because that's cosmology, see? You can be 38 and 12. Yeah, why not?
But we're not seeing that distant point as it is now, but as...
Of course, like when you look in the mirror, you might be 38 and 12 and 150,000 years old, but when you look in the mirror, you don't see yourself being 12 or 150,000 years old. Don't be silly. No, you are 12 and 150,000 years old, but you're also 38.
Shortly after the universe began. And the ongoing expansion makes things even worse. The bottom line is that if we're ever going to try and explore other galaxies, we better get cracking.
You freaking moron. So I'm going to go back. Greetings to all the new people in the chat. I'm going to come in the chat in a second. And I'm going to show this again. for you folks who joined more recently. I'm going to rewind a little bit so you can see, so you have put this in context. And this is
beyond the moon, with later upgrades hoping to shuttle at least 4 years and weighing around.
This is, okay, NASA's 2024 Artemis moon landing mission explained. That's right. They're going to go to the moon again in 2024. Unless, you know, plans change. Okay? But anyway, in 2024, they're going to go to the moon, and this is what, well, it might look like. And they're going to show a rocket going out of Earth's atmosphere.
1,600 metric
Not those crappy cartoony ones. You'll see.
tons. The SLS Block 1 will generate 39,144 kilonewtons of thrust at liftoff.
Ooh.
That's about 15% more power than the Saturn V rocket.
Ooh.
It will be able to carry more than 26 metric tons of cargo to orbits beyond the moon, with later upgrades hoping to shuttle at least 45 metric tons.
Ooh.
Once the SLS is completed, NASA says it will be the
This. See that rocket having taken off there, Florida. Okay, let's go for Mexico. Off into space. You're seeing it here. Okay, that's the Earth. Okay, and that's the rocket off into space. This is brainwashing for the mentally feeble. This is brainwashing for the vulnerable. Now, I'm gonna take the audio off, and I'm just going to point something out. The footage that you're seeing, which is obviously CGI, has had an extra element put to it, which is the smears on the window that you're seeing to the top right of the screen. Those are smears that look a bit like fingerprints and things. It's indicating you're seeing from the interior of somewhere where between you and the external world there's some transparent barrier like glass, perspex, something like that. Okay, to make it have the illusion of being more real. And they've incorporated a little bit of camera shake. You'll see now, okay? Can you see the little bit of camera shake? That's to give the illusion of reality. That's to hoodwink the vulnerable. We've just seen that man, that clown foot, this guy, trying to convince people that time is two entirely different things at once, and that motion means motion and the opposite of motion. That's right. Now we have these people hoodwinking the vulnerable into thinking that rockets go out into outer space and they will be going to the moon to, well, missions, building, and people staying over, holidays, all that kind of stuff. And they're brainwashing the vulnerable like this young woman. And this is abusive. Now, I'm going to say again, I have, well, I didn't say this earlier, but I'm going to just flesh it out. I have looked after people with cerebral palsy. People with cerebral palsy, most times, there's an entire full individual in that body. Sometimes there's also mental retardation. But oftentimes there's no mental retardation. It's a problem caused by lack of oxygen to the brain in the womb. So they can't move properly. This does not mean they can't process the world properly. But it does mean that they are vulnerable. They are certainly vulnerable. I'm going to play this video again, and we're going to see a vulnerable young woman who has been brainwashed by these people into thinking that what these people are doing is really going into space, and is going to use her time trying to make things better for the future of humanity, not knowing that all of it is a waste of time. This competent young woman could be spending her time working on robots to help people in the real world instead of the imaginary world of the globe and of the globe space exploration. So watch, because apart from hoodwinking people like this young woman, they're also using these young women, this young woman especially, as a shield from criticism. The same as that Goethe girl, whatever she's called, with the autism regarding climate change, how that person is being used as a human shield. If you criticize climate change, you're criticizing this poor young woman. Now there's this too. If you're criticizing space missions and the ISS, then you're criticizing this woman too. So I'm going out of my way so for people to understand, I'm not criticizing this woman, I'm criticizing what this woman has been made to believe.
I got into a box because I wanted to help people and came with it, and I went Kung Fu books on the internet. So it was ridiculous. My sophomore year of college, I heard about a program which places people with disabilities in high-level internships. And lucky me, I got to do an internship here at NASA Ames.
Now, there will be people who will rightly be thinking, this is cruel. NASA's being kind, hiring this woman. Like, wait a second, that's not kind. If they're hiring her for her abilities, not for her disabilities. They're not hiring some poor little... No. If they're hiring this woman, it's because she's doing something that they benefit from. It might not be programming robots in the ISS, it might be being used as a mascot. But if they're hiring this woman, it's not as a selfless, saintly deed. So me highlighting this is not criticizing the woman or the fact that she might be employed. I'm highlighting the fact that this woman is being used as a human shield from criticism. And all of the NASA fanboys and girls, when they hear criticism of NASA, they will hear, but NASA, internally, they will translate it into, oh my God, but these people don't even know that NASA hires disabled people and they're attacking, and they don't even know they're attacking this noble cause. They're despicable for attacking this noble cause. And that's why she's employed, and that's why this is being shown on YouTube by, wait for it, NASA Video. That's right. This isn't some fake thing. Okay? So let's keep watching.
Working on SUV for the last 3 years. Astronauts have to do surveys of the ISS, and it takes them a bit of time. If we can create a payload for SUV to do that, then that would free them up to do more science.
So, this poor young woman's 3 years programming code for running this space robot on the ISS to free the astronauts so they have more time to do more science. This young woman thinks the astronauts are in space doing science. That's right. Obviously, but hook, line and sinker, the whole concept that the ISS is a space station in space, that there are missions to the moon and all of this. This is cruel. To mislead people like this is cruel. I'm going to play the end of it as respect.
Many tasks can be hard for me, so I really wanted to dedicate my work to making robots that can really help us in life.
Absolutely despicable. Now, on a completely different note, because I know people with cerebral palsy, and they can play video games, they can do all kinds of stuff. Okay, anyway, that's cerebral palsy and ability to do things. There are also crazy disabled people that do not have ability to do things, that demand that things be implemented so they can do things. In Britain, some years ago, we had discussion about the military improving possibilities for the disabled. Fine. Now that was NASA, and we know that that's not actually serious, it's just wasting that young woman's time. But the army is a serious thing. And there was a case of a man who was paraplegic, who was demanding to be accepted into the Air Force. So could they please change the planes so they could be flown with the arms alone? That's right. And have some crane system so he could be craned into it because he wanted to be a fighter pilot. And this went to the media and it went to the courts, and eventually the military said, "Are you freaking joking? Get out of here." Now, if NASA was a real thing, they would have done the same with that young woman. And that young woman would have ended up working for Toyota or Nissan or Mercedes, because she seems pretty driven and capable, doing real things. But not in charge of stuff that could blow heck up or kill people. So, this is the world we're living in. Now, I'm going to go and take a pee. I'm enjoying this, so I'm going to carry on. I'm going to look in the chat. I'm also going to make myself a coffee. I will be back in 2 minutes. I will then, now that we've heard that word salad from the cosmologist, okay, I'm going to read from the Book of the Sun. That's right. Thanks, Where's Wally? Because I've wanted to do this for a while. First, I will be reading the entirety of this. Jason, if you're watching, I'm going to read the entirety of this tonight. First, I will read the entirety of this, and then I will read a portion of the Book of the Sun. Harmon Walker, just so you're in the chat, you've highlighted. Wes Wally is in the chat and says, "You are a liar because he doesn't have a wrench. By the way, what happened to your faux sapien?" I don't know what happened to my faux sapien. Where's Wally? Where is he? 1 second, I'm giving wrenches. Where's Wally? If you're in the chat and you haven't got a wrench, I want to check that it's your real channel, first of all, and then I want to give you a wrench. And apologise. That's right. Don't not say anything, because I will just go through the chat and find you, unless somebody has deleted you, and give you a wrench, if that's the case. So I'm scrolling back through the chat, and then I will look at the more recent comments. Please just make a comment and say, "Hey Antonio, you sexy, sexy man, where's my wrench?" And I will give you a wrench. I'm seeing blue copper. I've given you a wrench. Yeah, you might be 12, but you're also 35. Where's Wally? There you go. There you go. Right, first I'm going to give you a wrench, and then I'm going to make sure that it's your real channel on some other fake channel. And if I made a mistake, then I apologise. See, that's what happens when you're not a narcissist. Now let me make sure that that is your real channel. It would be funny if it was a channel you just made up on the spot so that you could do that. If so, I would show that. Give me a second. So you have a wrench now. Where's Wally? What's all this about echo chambers? Oh, maybe also, where's Wally? Call Wolfie. Ask him to come in here, see whether or not he has a wrench. Because I'm not going to waste my time going and looking. I've seen that I know he's got a wrench. As does Simon Dan and Conspiracy Cats. Oh, no, this is the Where's Wally's real wait, is it? Yes. Wait. I thought you had more subs than that. Yeah, that is the real Where's Wally. Where's Wally? You're welcome, you dim. I'm showing how you're hoodwinked by the world. That's right. So you lied about that too, Antonio? There you go. Now you've got a wrench. Awaken Humanity great presentation, thank you. I'm gonna go. So where's Wally? Feel free to make a comment and test your wrench out. Thanks for that, Hammond Walker, because I hadn't seen, obviously. Wait, my system's freezing up a bit. Oh, I have a little drawing to show you all. Let me see. Oh, I think Where's Wally's in a little huff, because he's got a wrench now. Anyway, here's a little drawing. Let me make sure that it's going to show well. And then I'm going to go make a drink, go for a pee, come back. Here's a little drawing. Here's the start of the universe. That's also the start of time. That's 14 billion, 13.7 radius. Okay? And 4 billion years ago, Earth. Okay? Or 4.5, 4.6. That's time. Universe, time. Somehow, this is a radius. You might think that the diameter would be 28 billion. No, it's 92 billion. But remember, this 92 billion diameter is not really the size. The size is 250 times that 92 billion diameter made out of twice 14 billion years. That's right. Cockamamie nonsense. Back in a minute, folks. Ya Allah. Okie dokie. I'm back. I'm looking quickly through the chat. See, oh, looks like Where's Wally might have gone off in a huff. Oh, anyway, oh, right. I said while showing that word salad gibberish from the NASA guy. Just give me a second. I said that I was going to show that light does not travel in straight lines like they try to say. Because they still say light travels in straight lines. Like, it doesn't, dim dim. You could go and test your theories at the most simple fundamental levels. Does light travel in straight lines? Just check. You might say, doesn't. In which case, there's a lot of employment for a lot of physicists, a lot of future physicists. If you say to them, hey guys, the field is open, because turns out we were wrong about all of it. So what I'm going to do is show some photos that were passed to me earlier today. Just simple, nice photos. Let me sort my windows out. And let you see for yourselves that light doesn't actually travel in straight lines. Right. Now, does this mean that light doesn't travel in straight lines for any portion of their trajectory, of their path? No, it doesn't mean that. It means that it definitely travels in circuitous paths. Could some of those paths be straight? Yes, they could. Are they all straight? No, they're not. So I'm just opening a folder and then I'm going to share screen and you will see. I've shown this before. By the way, folks, I am the first human being to show this. I can't believe this, by the way. I can't believe that it's taken until 2019 for this artist to show this. And all I did was look. And you guys have all seen it too, in the real world, with your own eyes. You just haven't noticed. I'm not saying there's something wrong with you for not noticing. I'm just saying I'm amazed. So here they are. Okay, let me just open them first. These 3 photos are really cool. These were sent to me by Donald, so thank you very much, dude. And then I'm going to read, like I said, The Third Eye, Where It All Begins by Sophia Stewart. What is this book called The Third Eye? The Third Eye, according to Sophia Stewart, a complete lunatic crackpot who's not really a lunatic, she's just nasty. If she was really a lunatic, I wouldn't call her that because that would not be very nice. According to her, it's the actual manuscript for The Matrix. You know those movies? This is what, according to her, she's been giving interviews for a long time. I thought it was true when I heard her talking about it. Eventually, I bought the book to check to see whether or not it was true. I've got the book. I'm going to read the book. You determine whether or not what I'm about to read is in any way related to The Matrix or could be considered in any way to be related to The Matrix. But first I'm going to show these photos. Very cool photos. Now, some people out there, they know what barrel distortion is. So all cameras have barrel distortion. When Globalings have a problem with something, they'll say, oh, barrel distortion. And when they have a problem the opposite way around, they'll say, no, that's not barrel distortion. That's just Globalings for you. Let's remember, they can say that 14 billion years is 92 billion years is 400 and something billion years. It's, well, 92 times 250 billion years. That's right. 14 billion years is 92 times 250 billion years. That's Globlings. Right, display capture. Here we go. And you can see my cursor. Now, that's a pretty cool sun. It looks like the sun has wings. It looks a bit like, that famous image of Abashunipal, I think it is. Famous, or if you want, Zoroaster or Zarathustra. That image of a Arab guy, well, Arab region with a beard, sitting in a spacecraft with wings. That image. Look at the sun. But forget the wings. That's just very interesting parhelia. Forget that. Drop a vertical line from the sun down. Now bear in mind, this image, if I scroll up, if I scroll up, you can see that the horizon is slightly sloped. This means that he wasn't holding it entirely vertically. If it was held entirely vertically, the horizon would be entirely horizontal, and you would be able to tell with more clarity that the reflection of the sun is to the right of the vertical line from the sun. You can see it here quite clearly. This is not CGI. It's not some crazy distortion. This is the real world. In the Book of the Sun, I explain how this happens. And I'm going to read a portion of the Book of the Sun for those of you who haven't read it yet. Now, can you see how this region here is not directly underneath the sun, but off to the right? So that's one image. Here's another image. You understand? Drop a plumb line from the sun vertically down, and you see that it doesn't fall in the center of this reflection. Now, you might say, oh, it's just an incidence of the wind and the waves and the platelets on the waves just coincidentally, for that brief instant, showing the light a bit to the right. Well, this is not an instant. This is several instances. This happens in the real world. I first saw this with my real eyes in Israel, of all places. So type X in the chat. I'm going to look in the chat. Type X in the chat if you can see that this reflection is not directly underneath the sun. And that's with this slight skewing, which brings the reflection slightly closer to center. If you turn it slightly the other way, which will be rotate the frame slightly counterclockwise, you will see that difference even more. That's not a critique of you, Donald. That's just, I'm just pointing out a fact. Okay? Also, I think the red petals are fascinating too. It's just beautiful. The sun is such an interesting thing. So, there you go. Share that with your folks. And that's it. There we go. Now I'm going to go... dude, by the way, thank you very much. That is really cool. That is very, very cool. Right, let me see where the chat is. Please type X in the chat if you could see what I meant, or if you're still unclear. Right, I'm juggling windows. Oh, okay. Oh, that was cool. That's the first time I come back into the chat and there are that many X's. Okay, I'm now going through some of the chat, okay, and then I'm going to read first, because we've been listening to the BS. So we've been listening to the BS of the heliocentric cosmology. Then we're going to listen to the BS influenced by heliocentric cosmology and the heliocentric way of thinking, okay, which is, you can just bullshit your way through the world, with this woman saying that she wrote The Matrix, okay. And once we've gone over that BS and this BS, we're going to go over a chapter and a half, maybe, of my book and see whether or not that's BS too. Okay, so I'm now putting a wrench to FVM TV. Sorry, I'm just trying to give wrenches. Oh, you on your bicycle and your fire. Okay. Right. Yes, I know it's you and your fire. I just wanted to say Donald in case, you know. Anyway, let's see. 2-minute mark shows 2 suns. Chuck the Canuck. Okay, I'll have a quick look. Let's see. It could be showing 2 suns. It could be glare. It could be. But the 2 sun phenomenon is happening. Going to continue to happen. It's going to be seen by more people. And by the way, as somebody mentioned yesterday, the daylight saving is being dropped. Of course, so the world is being divided into 2. You can drop a defining line between fluoride, vaccines, NASA, 9/11, and that all being fine. So you got the people who are suspicious, like don't trust that, and then the people who think that all of that is fine. The world is being divided into 2. For those people, it's going to be NASA, moon missions, nonsense, and vaccines. For the other people, it's going to be interesting stuff, some of which coming from official sources, directly from official sources. Like that guy just slipping in that yes, the universe is flat, yes, the earth is flat, but even though it meshes flat, you could think that it's a sphere. And then say, but it is a sphere, link. Anyway. Right, I'm trying to see this video that was linked by Chuck the Canuck. Right, sorry, 1 second. Sunblock Sunday infrared, 2 light sources. It sounds very interesting. Let me see. I have Loki here. I'm just scrolling through the video. Oh. Oh, wait. Looks like 3 light sources. I'm not playing the video just yet, just in case it turns out. Yeah, I am going to play it. Can't say for sure, but I can't say it isn't for sure. So just give me a second. Very interesting. Right, let me see if this shows it. No, it doesn't. Okay, just give me a second. Here we go. The video was shared in the chat by Chuck the Canuck. So I'm not going to copy and paste it. It's already there. Just look for the channel Chuck the Canuck. And I'm going to rewind a little bit. Okay. I don't know what the audio is doing, but I'll play it with audio.
You could see the other one better, the one up top that was leaving the street. Okay, guys, so what do you think that this shows in infrared? Okay, this is what my exterior security cam that was facing the sun while I was at work, this is what it filmed. Now, what we're seeing here is the night vision setting. I had it on the wrong setting, but when I got home, I switched it to the daytime setting. So basically what it has is internal filter processors. They simulate a solar filter, they simulate a night vision filter. It does have infrared bulbs on it. It has a short range infrared spectrum or distance. And this, I switched it over when I got home to the complete sun recording, so daytime recording. And it uses a macro lens or some type of solar filter.
Now, I'm going to rewind a little bit. Anybody who's seen layered rainbows, where you have a rainbow immediately behind it, and you can see some spacing between the foremost rainbow and the rainbow just behind and the rainbow just behind. Anybody who has seen that will be able to process this information about the sun easier than people who have not. You sometimes get rainbows where you have the colours and then the colours repeat, but in very close sequence. So where you have the green and you'll then have the blue, you'll then have behind it the yellow, the green and the blue. And you can see there's a separation. This is what it looks like to me.
Switched it over when I got home.
It looks like that is the same type of circumstance.
To the complete sun recording, so daytime recording. And it uses a macro lens or some type of solar filter simulation. But as you can see, it's picking up a secondary object, just like the night vision setting was picking up a secondary black object. This is picking up a bright secondary object. Now, there is another one right above it. I think that is a lens flare, but I think that isn't the sun. I think that's the sun. I think what we're seeing here, let me pause this. I think what we're seeing when we seen it with the regular Nikon camera and you just saw a very distorted sun behind a bunch of chemtrails, I think what we're seeing here with the solar filter or the infrared simulation camera is this right here is where the sunlight is hitting the clouds. And because this is a special camera with a special filter on it, it sees past all the garbage and just sees the light. This is the sun projecting its light on to this cloud cover, that big chemtrail cover that's in front of it. And it makes the projection bigger because there's distance between the sun and the chemtrail cover, but not much distance, because if there was a huge distance, if this sun was 93 million miles...
Good guess, but no. So I'm going to go back to where he's discussing seeing it through the haze to see. Oh.
Going over the sun is there's going to be a secondary plane down here that looks like a normal plane, same height, not visible with the naked eye. You can only see it, you zoom in on it, and it doesn't leave a trail. So why is this one leaving a trail and the one that's down here that I'm about to show you isn't?
Okay.
You could at least
Never mind.
1,000 feet. I mean, you can't even see it unless you zoom way in. You could see the other one better, the one up top that was leaving the street. Okay, guys, facing the sun while I was at work.
Oh, okay.
This is what
yeah, it's not what he's saying it is. It's a double sun. Thanks for that. Okay, so let me get rid of that. Give me a second. There we go. Thora Odinson, greetings. I'm just quickly going through the chat. Yeah, other people. Okay. Right, so let me make sure I'm showing what I think I'm showing. Yes, I am. Let me turn, get comfortable. If anybody wants to contact, oh, it doesn't matter, I'll do it afterwards. But I was going to say, if anybody wants to contact Persian Scribe and let him know that I'm going to be reading this, The Third Eye by Sophia Stewart, who claims that the story you're about to hear, and I'm going to read all of it, by the way, you might think it's going to take a long time because, you know, thickish book. Don't worry, it's not. I'm going to read the story in its entirety. See, the reason it's thick is that the story is repeated in various different formats, including original manuscript in the original horrible font, and then 2 other times, and then a whole series of letters that she has written to people saying, I wrote The Matrix. Okay, lots and lots of letters that she has written to people. This is her supporting evidence that she wrote The Matrix, because you see, she complained to people saying that she wrote The Matrix, therefore she did. So I'm going to read it. And I thought, when I first heard of this, it was a Coast to Coast, gave her a platform. Oh yes, really? Oh, so they stole the story from you. That's interesting. You think, considering the book is available on Amazon, that they would have bought the book, read it, and then decided whether or not to give her an interview. So, let's go. Foreword first, and this is just a little critique. There's a foreword and a preface and an introduction. I'm just saying, you know, there are writers out there who know exactly what I mean. Okay. Foreword. For humanity on planet Earth, there are only 2 eyes. But in the universe, there is a third eye. It is an all-seeing eye that reveals all. Enlightenment, power, wisdom, everything. This third eye endures in the Great Seal of the United States of America that harbors on the back of a dollar bill. That's the foreword. This is a preface. Far out in space, and by the way, when there are typos, I will read the typo. I have many typos in my book, okay? And when I read my book, I'm not going to read the typos. But I'm going to read the typos in this. Because I haven't been writing to people complaining about them stealing my stories, or my ideas, or anything. You think if somebody was going to, then they might fix their typos. So, just saying. And I will be fixing the typos in mine for the next print run. So here we go. Far out in space, a great battle took place, and something from the battle that was flung to planet Earth. I'm reading what's written. It was something that was defeated on its own planet and, therefore, not allowed to remain any longer. It was thrown out. The thing was huge, though invisible, and, although one could see it, I'm reading it how it's written, so a break after the comma, okay? And although one could not see it, one could feel its power and hear its breathing. Depending on its effects of the individual mind, every imaginable evil was perceived. This huge, powerful thing came here to rule. In fact, it was given Earth to rule and was not going to be denied. It brought with it many wicked images and, with the help of these images, every area of planet Earth was covered. It now had dominion over the air, the land, the people, the entire planet. and this was its new kingdom. The thing knew that its success depended entirely and only upon deceiving the world. That's the preface. This is the introduction. Watch the heavens, we will be back. For those who don't know, I'm reading The Third Eye by Sophia Stewart. This is supposed to be what The Matrix is based on. Yes, they were here and they promised to return, those aliens who came to Earth many thousands of years ago, but their return would not be for the purpose that everyone believed. Those aliens of long ago knew the time would come when the forces of light and darkness would struggle for dominance over the spirit of man, because universal death for mankind was inevitable. They knew that great changes would take place in the future, most of which would lead to strife among humans and the ultimate destruction of the planet Earth. They anticipated a period of great famine, high prices, chaotic conditions, and devastating plagues. They knew that only a revolution would make it possible for the utopian age to come into being in the course of time, but not without a price. Chapter 1. Earth's Past. Before there were any inhabitants on Earth, other beings existed in the galaxies of the universe. Some of these beings were not as we know human life to be. Rather, they were alien in composition and structure, with some existing in other states as pure energy. Life itself could have come from beings such as these. In fact, these beings may have evolved on a planet similar to Earth on an uncharted galaxy. Many centuries ago, planet Earth was beautiful and peaceful. Gardens of flourishing flowers, plants and beautiful trees, abundant with fruit, could be seen everywhere. Everything was perfect bliss and in perfect harmony. Then, Earth had visitors from space, who came to see how the planet and its inhabitants were progressing. The people of Earth had open communications with these aliens, whom they believed to be gods, and never did they forget the gods from the sky. Stories, artifacts, and drawings relating various encounters and friendships that were formed with the sky gods were passed down through many generations. Also, the people of Earth occasionally mated with the visiting aliens, and from such breeding, many new races emanated. The most important thing, it's worth it, folks. It is. It's worth hearing what the story that this woman is trying to pretend was the source for the Matrix actually is. Okay? The most important thing that these aliens brought to Earth was knowledge. It was through this knowledge that the people of Earth learned many things, old and new, including many secrets that were revealed by the super hybrid races. In time, therefore, they became a new source of knowledge and power. Earth progressed, with some of the new races being giants and one-of-a-kind life forms, all unusual in appearance because of the bizarre mixtures that resulted from mating with the unknown aliens. I thought I had open communication with them, but never mind. I will not editorialize, because, dude, if I do, I'll never finish. The aliens knew that mankind on Earth would one day annihilate itself, but they promised to return. Also, they knew that in the near future, about 1,000 years, the Omega would occur, and when it did, Earth would be destroyed by fire. All human life would be wiped out, and an imbalance in the universe would be created. Knowing all of this, why would the aliens want to return to a planet that was to perish? Their reason was clear. They planned to intervene in the affairs of men. They would colonize, and they would mate with humans. Their sole purpose was to speed up evolutionary changes in humans to the extent that they would immediately evolve into a super race. These evolutionary changes would make it possible for mankind, once hybrid, to become immortal, never experiencing death, then to become very progressive for centuries to come. A picture. You don't need to know what it's about. It's not about anything really. Chapter 2. Planet R. That's A-double-R. Years ago, in a very distant galaxy, there was a planet called R. Its location was secret, only because it existed in an uncharted galaxy millions of miles into space. Peace reigned on the planet, and because of this unique factor, a superior race of aliens developed. These aliens were all beautiful beings of light who had been conceived of pure energy. Their sole purpose was to bring harmony and order to every living thing in the universe. They were the preservers of life, the guardians of the universe, and because of their purpose, they grew more beautiful and bright with every minute of every day. The power of this unusual planet came from a source called the Eye. This power was also the life force of the inhabitants of the planet. Because it was their life force, the location of the Eye was a secret known only to them. They knew that the Eye existed on Ob 3, a planet in the same galaxy as their own. The energy of the Eye was controlled and used by Mikod, their leader, who knew the mysteries of the energy. Mikod believed, or Mykod, M-Y-C-O-D. So I'm going to say Mikod. Mikod believed the one who controlled power should not misuse it, for power wrongly used will only bring destruction. He who controls the power must have desires that will be only for the good of the whole, not just for self. That's in quotes. The Eye, always in a natural state, contained no impurities. Therefore, the prime function of Mikod as ruler of the planet was the same as that of the sun. He continuously distributed the energy of the Eye. Thus, Mikod became the giver of life, and because of his leadership qualities, the universe constantly flowed towards knowledge and light. Mikod assigned tasks to each of the alien inhabitants of the planet, enabling them to play intricate roles in the design of things to come. Don't worry, we're probably halfway there already. The aliens were dedicated beings. They worked hard and obeyed happily, except for one. This alien was exceptional, more beautiful and gifted than the rest. Everywhere he went, he brought a light as beautiful as morning itself. For this reason, he was called Morning Star. Although all his fellow aliens raved over him and praised him, it was not enough for Morning Star. No, Morning Star wanted much, much more. He wanted not only glory, but also power. He became so obsessed with this desire for power that his greedy ambitions embodied him with evil, and it was not long before he decided that he should rule. Sorry, maybe I shouldn't. Never mind. Morning Star's greed turned him into the opposite of himself. His brightness and beauty reversed. He was no longer bright and brilliant, but dark. The aliens of R knew nothing about darkness and how to cope with it. Then, much worse, Morning Star turned completely black and began to throw off negative charges that brought harm and disharmony not only to planet R, but to the entire universe as well. I should mention, the writer is black. She's Negro, of the Negro race. So when this person goes black and bad, bear that in mind. With his increasing darkness and power, Morningstar began to consume all other aliens that he came in contact with, and they, in turn, became images and shadows of himself. Morningstar developed a desire to rule not only planet Earth, but also the entire universe. He felt that he had built a strong army, and he was very powerful, powerful enough to overthrow Mikod. Plans were already made for the future of planet Earth, but just prior to carrying out these plans, conflict surfaced between Mikod and Morningstar, whose power was now almost equal to Mikod's. Fortunately, Mikod and the aliens who served him had not given Morningstar enough time to consume all that he needed, and they knew that Morningstar would have to leave planet Earth very soon. Apologies. Because he was creating a tremendous amount of harm and dissension. Therefore, a plan was formulated to send Morningstar to Earth. Yes, thought Mikod, if Morningstar wants to rule, I will give him a planet to rule. It was not going, that by the way is not in commas or anything. It was not long before Morningstar's greed and desire to rule brought about a great battle between Mikod and himself, with Mikod emerging victorious. The defeated Morningstar was banished to Earth to rule, with a promise that he would reign only for a short time because a strange prophecy was to follow him. This is the Matrix, according to this woman. Mikod was to be the first to initiate evolutionary changes on Earth by mating with a human. The first hybrid child born of the mating would one day receive the power, and from that child a new race was to come. With the coming of the first child, Morningstar would know that his time was drawing near. At the age of 30, this child would use his own power to end Morningstar's reign and evil and restore peace. With the prophecy in mind, and immediately upon his arrival on Earth, Morningstar established a government directed towards finding and destroying the first child, so that the prophecy would not be fulfilled. A little bit of contradiction? No, never mind. Let me take a sip. I'm going to look in the chat. If you're enjoying this, folks, or if you don't mind at least, type X, let me know. Okay, there's not much more to go, honestly. Morningstar feared the prophecy, but he believed that he had a good chance of keeping it from being fulfilled. He knew that he had the power to change the course of energy from positive to negative, and that, if he used his powers to consume all of Earth, he could then destroy the promised seed that was to defeat him. Since the one who was to defeat him was not to be born for many years, Morningstar had a great deal of time to plan his own success, for the prophecy was to take place in 5000 BC. In space, there is no time as we know it, there is only light. Therefore, as Morningstar made his rapid descent to Earth, great changes were occurring. The great civilizations of Earth were deteriorating by the millions and fast becoming lost civilizations with lost knowledge. No one could shed any light on the mysteries of the world or the universe. At one time, Earth had everything, and there was nothing that had not been done or said before. However, now, even time itself was going in a backward motion. Indeed, Morningstar wanted no time in using his power to change the course of energy, and this change immediately brought about undue influences. A strange phenomenon occurred, almost simultaneously with his descent to Earth. Changes were already taking place in space, but the closer Morningstar got to his destination, the more apparent the changes were on Earth. Many light years away, Morningstar came hurtling through space from his home planet, as though he were a large burning network full of flames headed straight for Earth. He entered Earth's atmosphere in a flash of brilliant light, but after he reached his destination, the entire universe was engulfed in blackness and began to change gradually from a positive to a negative energy. As time went on, more and more disharmony and strife caused less and less order with everything else, and so greed had come to Earth to rule. In the beginning, remember, this is the Matrix that you're hearing, supposedly. In the beginning, before Morningstar's arrival, but due to an invisible influence, the Earth was good, new, and ready for a conqueror to overpower it. From the time man tasted his first piece of meat, he not only grew in wisdom and knowledge, he also became as wild and aggressive as the meat he ate. The fruit no longer pacified his conscience or his convictions. All too soon, there was power on earth that made men kill each other. Work in exchange for money was next to come. 1/4 of Earth's population suffered from war, famine, disease, and wild animals. Thunder and lightning, earthquakes, hail, and fire mingled with blood, because nature turned against mankind. The year 2110 AD brought many great changes on Earth. Mankind had just finished experiencing the last of the atomic age, when an evolution of awareness began, and man was going from the unconscious stages of evolutionary development into the conscious levels of it. There was no doubt that Earth would be destroyed. Before the destruction of planet Earth, there was to be 1,000 years of peace and harmony that was to pave the way for a super race that was destined to come. This super race would not be touched by death, and with its coming, peace would finally be established. For the moment, however, Earth and its inhabitants were advancing towards evolutionary awareness. They were prepared because they had been cleansing the inside of their bodies for the last 100 years, and because of this preparation, the cleansing of their minds had taken place. Just 2 years before the glorious reign of peace was to take place, Morningstar appeared as the first friendly alien to come to Earth. A demon companion by name Megos, an evil alien from the same planet as Morningstar, came to Earth before Morningstar's arrival and convinced the people that they should accept Morningstar, because he was indeed their crown liberator. Since Megos came to Earth in human form, the Earth people did not know that he was one of the evil aliens sent by Morningstar. When Morningstar arrived on Earth, the businessmen were already gaining power. It says businessmen were already gaining power by using their business management ways to get whatever they wanted. Now, Morningstar gave a very influential gift: deceit. They used this gift of false magic and soon deceived all the people of the Earth. They corrupted Earth with immortality by using and selling the most advanced machines known to technology, and this power took peace from Earth. For years, Morningstar expanded his government and firmly established it. He brought about new changes, and all the people on Earth believed that they had experienced miracles. Then, Morningstar's reign was drawing to an end. All signs of time reminded him that the arrival of the promised seed was upon him. Yes, the child's birth was due to take place somewhere in the century of Earth's time, and at 30 years of age, this child was to lead a great revolution, a battle between good and evil. The Industrial Revolution had faded, and soon there was nuclear power to take its place. The rebellion that Morningstar anticipated would soon begin. Weapons of mass destruction with which to erase human life from Earth had multiplied. Soon there would be a nuclear war between different nations on Earth, and, as predicted some 5,000 years earlier, Earth would be destroyed by fire. The firing of the missiles would destroy all the nuclear power plants, and the China syndrome the Western world feared would occur. The firing of the missiles would cause the nuclear plants to drop their radioactive loads and fuse them into the core of the planet. A nuclear chain reaction would then cause the destruction of Earth 1,000 years later, and its land would be nothing more than craters of radioactive lakes and sulfur pits of burning fire. Democracy was a word remembered by few, forgotten by many. A dictatorial government had taken its place. All the great cities were destroyed, and a new world government was formed. At this point, Earth's government was based on the pyramid system, and the worship of the almighty dollar prevailed. For years, the mystery of the pyramid had evaded the masses, but now they understood its meaning because this governmental system was structured exactly as the pyramid games played in the last half of the 20th century. Everyone knew the pyramid's trilateral structure. Trilateral. Pyramids have 4 sides. 4 sides, not 3. Everyone knew the pyramid's trilateral structure and its resemblance to a triangle because it was bound by 3 sides and had 3 angles. The pyramidal government was capitalistic. Its masses at the bottom supported the very rich, the very few at the top, and all were kept. Sorry, folks, I've got a very sore eye. And all were kept in force by 3 levels of authority: Morningstar, alien power; the Rothfellers, that's a funny play on words on Rothschild and Rockefellers. The Rothfellers, their 7 major and 10 major corporations, and the last president, who was Sam Emin. He was called the last president because he was critically He was called the last president because he was critically wounded and was expected to die. However, the wound healed, but he never fully recovered. Instead, he received from Morningstar his own power, throne, and vast authority because he and the alien became the same man. I say. After the president's miraculous recovery, the people of planet Earth were amazed and followed him. Everyone worshipped Morningstar because he had given his authority and life to the president. Following this, the president was permitted to make proud claims, which were insulting to all and was good, and was permitted to have authority for 3½ years. The true power, however, was held by Morningstar, Megas, and the Rothfellers. Remember, this is the Matrix you're hearing. You're hearing what's supposed to be the Matrix. Megas' job was to do all dirty work for both the Rothfellers and the last president. The image of the last president was preserved and worshipped by the masses throughout the world and was kept in force by Megas. Throughout this chain of power, all people, small and great, rich and poor, slave and free, were forced to have a laser mark placed on them, without which no one was permitted to buy or sell. Wow, how imaginative. Unless they had the trilateral laser mark of the pyramid, they were not allowed to conduct business of any kind. As soon as scanners were set up, the mark was placed on their right cheek. Religion no longer served mankind's needs or purposes. The people no longer had time for it, nor did they have any time for leisure. The only factor on Earth that was of any importance was getting money with which to satisfy mass hunger. Democracy was killed the moment all aid programs, welfare, social security, and taxes were eliminated and the draft was brought into full force. Acid rain fell from the sky, causing water to turn bitter, and many people died from drinking it. Fire, smoke, sulfur fumes, and radiation waste from the nuclear power plants brought about many plagues, and people could not eat from Mother Earth herself. Because no one could eat or drink from the earth, everything was in great demand and had to be bought. The nuclear wars had destroyed all the great cities, except for one called the Dome. It was a giant, computerized city protected by a shield of invisible, energized beams that destroyed all types of germs, artillery weapons, and radiation fumes. It was Morningstar's power base and was controlled by the 3 levels of authority. Here, everyone came to buy or sell because it was self-contained. Soon the bartering system came into being. Money became scarce, and bartering became more precious than gold, silver, or diamonds. The bartering system allowed the performing of a service in exchange for receiving another service, thus eliminating the need for money. The laser mark allowed all those who bore it to be part of this system and, thereby, totally independent of money. Most of the people took the mark in favour of starving to death. However, the mark bought them, inverted commas, and they incorporated them into the system. They had no need for money, food and clothes because the system provided everything, but they were no longer free. If they did not take the mark, they risked starvation unless they had other means of getting food. The horrible nuclear wars brought 2 organizations into power. Members of Earth's largest banking institutions and corporations secretly banded together in a final effort to maintain the worship of money as a permanent way of life. By controlling the mass media, television, newspapers, radio, and print, the secret organization with the codename Rothfellers convinced people on Earth to rebuild their weapon systems as a means of providing money and jobs for everyone. Computer games such as Tron, Space Commander, Defender, and Pac-Man replaced Monopoly and other home games during the last of the 20th century. The games were a scheme of the Rothfellers, with the aid of President Sam Emen, to secretly prepare young boys and girls for nuclear wars by programming their minds to handle computerized warfare. Such preparations would be useful once a draft was brought into full force. Meanwhile, Morningstar and Magus had another purpose in mind. There were subliminal messages in computer games that were to be picked up by the unconscious minds of the people who played them. Russians, therefore, were not permitted to come into contact with these games. Also, these games had a 2-fold purpose. One, to make money, and the other, to teach. Everyone knew that. In the future, the computer would be the master of one's fate. War had begun, even before the new weapon systems were finished, and most of the population abandoned the pursuit of evolution or died in nuclear battle. Handguns and all other guns were abolished, because the masses believed them to be dangerous, and giving up their use made it possible for the Rothfellers to become tyrants. The second organization in power was formed to free the masses from the influence of the pyramidal governmental by giving them jobs. That was I didn't misread that, by the way. By giving them jobs and the means by which to form businesses, in order for them to buy and sell without taking the trilateral laser mark of the Rothfellers. The Rothfellers traded only with their own, and one could not buy from them or sell to them without the mark. This second organization's, get in there folks, secret codename was the 7 Heads, and each member had their laser mark on a different head. This organization set up to decoy those who would destroy Earth, and to help fulfill prophecy by revealing the truth to the masses. This prophecy was the same as that passed down through the generations, that a super race would come to Earth. The prophecy may have been born out of a desire to be free from oppression. Whatever it was a rumour long forgotten by some, but for the bitterly oppressed it was well remembered, because the oppressed dreamed of the day when they would be free. They did not care where help would come from. One thing gave the people strength. They knew their salvation depended upon the coming of a future child and the power of the third eye. It was true that this power could be used to rid Earth of all its poverty, disease, sickness, death, and all kinds of destruction, but the question of who was worthy of receiving this power remained. This question was constantly asked by the masses for many years, but there was no one in heaven or on earth or in the world below who could receive this power because the one was not yet born. That's the basis on which Sophia Stewart says the Matrix is based on this, because she used the words the one and it's underlined. That's right. Regardless of the golden child also being the one and many other. Anyway, this remark so startled and frightened. Oh, sorry, I jumped ahead. Chapter 4. There's only a couple more chapters, folks. Some of the pages I'm turning only have pictures. Yeah, we're almost there. Chapter 4. Iseul's journey. There was a woman from Judea who, from her appearance, seemed to be of lower birth. However, this was not so, for she was a direct descendant of a king who once ruled Earth many thousands of years ago. What king, no one remembered or cared. She travelled the road that led to the great city, so called because it was self-contained, and was the only place one could go to buy or sell. It was the largest city not yet destroyed by the nuclear wars. It was invincible. This great city was called Dome. It was the largest computerized empire of this century. Every day, hundreds of people were on the road to this city. Mass hunger was everywhere. So all small areas and towns got their aid or trade from Dome. On her way to the city, with some of her relatives who were all seeking aid, Iseus came upon a crusty, very old gypsy woman who was dying by the wayside. I'm going to read that again, because this is, what's it called in the Matrix? The future teller. In the Matrix, in the film The Matrix, I'm looking in the chat. Yes, Highlander 2, P. Murray. What's it called? In the Matrix, the black woman that tells the future. Anyway, that's who this is now describing. What's this? Andral, you can have a wrench too. This is The Matrix. What you're hearing, believe it or not, is The Matrix, according to the woman who says that she wrote The Matrix but called it The Third Eye, Sophia Stewart. On her way to the city with some of her relatives, I saw, we're all seeking aid. Iseus came upon a crusty, very old gypsy woman who was dying by the wayside. Iseus felt sorry for her and gave her a drink of water from her canteen. After the old woman drank, she took one last breath and said, "You are to give birth to the one." This remark so startled and frightened Iseus that she dropped her canteen, wasting all the rest of her water. The woman's remarks reminded Iseus of what she constantly had been told as a child by her mother. "We are descendants of a great one. Always remember that. You have nothing to be ashamed of because we are poor." Soon after the occurrence with the gypsy woman, Iseus met a strange man with clear, transparent eyes, to whom she became deeply attracted. He spoke profoundly and had a hypnotic effect on Iseus. Indeed, she was extremely impressed with him. But when she asked his name, he assured her that this was not important. What was important was that they had met, and they knew they were meant for each other. That night, for the first time in Iseus' life, she slept with a man. A man to whom she said, "Hey, what's your name?" "Don't worry about it, all that matters is who we met." A man with intense ice and hypnotic effect on her. They made love throughout the night, and for the first time, Iseus was happy. However, her happiness was short-lived, because the next morning, the man with no name was gone, and it seemed as though he never really existed. Oh, sorry, I misread that. And it seemed as though he ever really existed at all. Soon thereafter, she began to forget him until one day, several months later, she realized that she was pregnant. During the last few days of her journey to Dome, she was about to give birth, and the pain and suffering of childbirth made her cry out. For some unknown reason, Morning Star heard her cries and stood, invisible, in front of her, waiting to take her child and destroy it. This was not to be, because a second, unseen power was also there, this one to protect the child. Iseus gave birth to a son who would one day bring peace to Earth. When the Morning Star realized his opportunity to destroy the child had escaped him, he began to pursue the woman. However, Iseus fled to the desert where was given help. She was taken care of for 3.5 years, safe from Morning Star's attack. Morning Star was furious that the woman had escaped him, and he went off to fight against her relatives and those who were faithful to the truth prophecy. The child was named Ican. That's right, the child was named Ican, and was taken by members of the Seven Heads to a safe place. For the next 12.5 years, the child was raised as a girl, which, according to his papers, was for his own protection. At the age of 13, he was given to Vashta, a ruling brother of the Seven Heads organization who, unknown to others, was a spy in the Rothfellas organization. Morning Star searched everywhere, never realizing that his enemy was in his own camp. Chapter 5. The birth of Ican. At his birth, the sky turned black and the sun did not shine. Heaven and earth shook with multitudes of earthquakes. Many stars fell from the sky, and many phenomena occurred at his coming, because he was the only one worthy to receive the knowledge and power of the Eye. His name was Ican, and he was the leader of the Galactic Rebellion. He was 30 years of age when the revolution took place on Earth. He had a warm face with strong fixed eyes. He stood 6 feet 3 inches tall and weighed 185 pounds. At all times he was dressed in black, because black was the dominant color code for the Rothfeller organization. He was the seed that the prophecy promised, the one for whom the multitudes had waited so long. He had finally come to fulfill his duty and to destroy Morning Star. Morning Star waited many, many years for the coming of Ican and had prepared everything well in advance for his arrival. He devised many systems with which to find Ican. One system was for the last president, Sam Emin, to wipe out taxes, social security, welfare and aid programs, anything and everything that forced the people to take the mark. Then he thought the draft system would system into full force, so that Ican would be killed in the nuclear war once he came of age. He did much more to find the child, but what he did not know was that the child was being educated right under his nose in his own Rothfeller organization, with the aid of one of his greatest warriors called Caracus. Before Ican's 30th birthday, he designed and constructed a space vessel called Space Star. It was a huge vehicle shaped like a pyramid, designed for interplanetary warfare and space travel. It was to be the flagship of Earth's space fleet, and it contained the most secret and highly advanced mechanisms known at that time. Ican did not know that the Rothfellas would one day command him to use Space Star as a vehicle for war against the people who registered the Rothfellas' tyranny. With the guidance of Caracas, Icahn grew in strength and wisdom. He was an able young man, and when Caracas noticed how hard he worked, he put him in charge of all armed forces of the Rothfeller organization. Chapter 6: The Rebellion. Space Star is at the orbiting dock. Its crew members are waiting for their assigned orders, which cannot be given until Icahn receives his secret orders. Icahn is beginning to change. He does not feel right about his mission, but accepted the assignment with reluctance. Just before beginning the assigned mission, Icahn personally experiences a happening that becomes manifest in the form of an eye. He sets this occurrence aside as being simply a hallucination and continues bringing in only the finest, most highly trained people on Earth to operate Space Star. The preparations complete, the vessel leaves the orbiting dock where it was constructed, at which time Icahn experiences another happening and once again envisions the eye. Icahn discusses the event with one of his close associates, who informs him that some members of the Space Star crew are rebels against the Rothfellas, and that they have stolen galactic maps of the universe from top-secret stellar receiving stations. They are pointed out to Icahn and confess that they possess information concerning the main source of power, the Eye, and that it exists on a planet called OB3. They explain that this planet is far off in the distant universe. More importantly, the rebels produce evidence to Icahn that the Rothfellas intend to control Earth's population and reduce it to only industrial object worshippers, and, further, that they intend to systematically destroy the concept of good. They explain that he is the chosen who is destined to stand before the Eye, and that he is to bring the power of the Eye to Earth. Icahn retires to his quarters for meditation and receives notification from the Rothfellas on Earth to open his secret orders. He does so. He finds that the orders clearly specify exactly what the rebels on board the Space Star had reported. Icahn is infuriated that he has been tricked into leading an expedition of destruction that will eliminate peace on Earth. He then calls all the people of Space Star together and reveals the information he has received, and everyone on board votes to join the rebels. Consequently, the Rothfellas on Earth inform Icahn that they will hunt down the valuables, Space Star, and execute all of its occupants. I'm reading as it's written. Chapter 7: The Escape. 1 hour before Icahn reads his secret orders, Morningstar finally discovers that the enemy has been searching for is Icahn. Knowing that Icahn is at the orbiting dock, he sends Megas to destroy him. However, just before Megas reaches the dock, Icahn reads his orders, and believing that Morningstar will try to stop the Space Star from leaving, he devises a plan to throw off Megas until he can escape. Using his alien power, Icahn sends out an optical projection of himself for Megas and the Rothfeller soldiers to battle with. While the soldiers battle with Icahn's projection, Megas realizes that he has failed and that his prey is now escaping. He knows, too, that someone else would be very upset to receive the news of his failure. At first, Icahn and his crew members travel through space simply to escape capture by the government of Earth. However, this ambition swells to a point where they join a galactic rebellion to overthrow the government. Unbeknownst to Icahn, Morningstar has commissioned other space fleets to search out and return Space Star to its crew to the dictatorial government. Additionally, Morningstar offered a generous reward for its return. Space Star fights many battles with Earth's fleets and pirates, and also experiences space storms Many of the Space Star crew are wounded and some die, and the crew is now reduced in number and forced to land on a nearby planet called SOR, S-O-R-R, to refuel. Fortunately, while in space, on the way to the planet, Icahn develops his alien side and comes into power. Chapter 8, The Adventures of Space Star. Don't worry, it's only one page, The Adventures of Space Star. Chapter 8, Adventures of Space Star. Icahn and his crew land on a beautiful planet called SOR. Its beauty comes from its radiant black moons, and the light from SOR is such that it encompasses everything in darkness. SOR does not bend itself to accurate navigation unless a space vehicle is within at least 1 million miles. This planet is governed only by machines of all varieties, which are completely operated by energy obtained by connecting into the power from the moons. The space connection between this planet and Earth lies in these machines. Modern technology is traded or sold to all who have ships sailing the seas of space who want to become rich. The planet is controlled by an alien queen called Janie, who rules with the Rothfellers of Earth. And machines get their power from the rocks found on the dark sides of the black moons. When Icahn lands on the planet, he soon meets with Queen Janie, who agrees to help him with his repairs and promises medical attention for the wounded members of his crew. Unknown to Icahn, however, she informs the Rothfellers on Earth about the arrival of Space Star. Queen Janie is an exceptionally beautiful woman who possesses the unique capability of changing the colour of her skin to reflect her inner emotions. Unfortunately for her, she comes into intimate contact with Icahn's alien energy that penetrates her machine-controlled consciousness, and she falls in love with him. At the last minute, Janie helps Icahn and his people to escape from SOR, avoiding the oncoming war fleet from Earth. Icahn escapes, but the Rothfeller soldiers capture and hold Janie hostage for her deceit. This causes Morningstar to become so angry that he destroys SOR. We're nearly there, folks. Now, the last chapter, which is interestingly enough called The Climax. Okay. And it's a page and a half long. Icahn heads straight to the planet OB3, where the energy is located and orbits around it. By this time he has been informed that his physical strength, he is a hybrid, enables him to stand before the Eye. He is, however, cautioned that if he contains any amount of impurity, he will die from his encounter with the Eye. Moreover, he is informed that if the people of the Space Star want him to possess the power of the Eye, they must first die for their own impurities as a testimony to their belief that Icahn's own purity and identity. Okay, that's how it's written. The people on the Space Star decide to die for Icahn, and they descend to the planet OB3, where flashes of lightning and rumblings and peals of thunder are occurring. The surrounding heavens blaze with fire and other phenomenon as the people stand in the open. Never before has a human set foot on this planet. The Eye appears and slowly opens. A brilliant gold light shines from it, and all the people die, except Icahn. He stands transfixed, beholding the wondrous sight of the Eye. Staring as though in a daze, he feels lost and empty. He is deep in thought. He realizes that it is now time for him to receive what he was created for. It feels to Icahn as though ages have passed since he first began this mission, but now all is clear and it is time. He is blinded by the brilliancy of the Eye. Slowly, the clothing on Ican's body disintegrates. It is time for him to receive the power. And it would go... Sorry. And it could go no place but inside him. Let me read that again. Slowly, the clothing on Ican's body disintegrates. It is time for him to receive the power, and it could go no place but inside him. The energy enters, and he lies naked and still on the plains of OB3. The sounds of emanate from the heavens. He lies still, as though he were dead, because his human side was destroyed, because of the energy entering him. However, he is reborn. He stands alone, feeling empty. Suddenly, one by one, every person who died for him walks out of his body. Once again, the plains of OB3 are full of people happily facing the blind Ican. He is surrounded by magnificent rays of light that slowly form into two golden beads that replace his useless eyes. Slowly, he raises his eyelids and sees the people who appear before him as all the races on Earth, other planets and stars. It is the super race of the universe that has walked out of him. Never again will they hunger or thirst, nor will any sun or heat burn them, because there will be no death. Ican, who is the center, will be their leader, and he will always guide them. His human side was killed, and by this sacrificial death, he brings to Earth the power needed to bring peace. The people of the super race go back to Earth in their alien form, with full knowledge that they must defeat the armies of the Rottweilers in space and on land. They descend to Earth amidst cheers of the multitudes now affected by the power of the eye within Ican. The Rottweilers are defeated and peace is proclaimed. The result of Morningstar's destruction is a reversal of energy. Positive energy begins to dominate, and the entire universe is no longer engulfed in darkness, and because it is no longer black, harmony is once again established. In the beginning, there was light. That's the Matrix, folks. Find the Matrix there somewhere. I especially like the vaguely veiled rape scene. I say, jokingly. That was The Matrix. According to the person who wrote that story is The Matrix. True story, like really. And that is the end. That's the end of the story. Where did I just put it? Where the heck did I just put it? That is the end of the story. What the heck? I just had it and put it down somewhere. Where the hell did I just put it down? What the? Huh? What the heck? Okay, sorry folks. This is very interesting. I can't see the book that I just read, that I just put down. Oh, here it is, dagnabbit, it was open. Anyway, the climax, that was very freaky. That's the end of the story. Now there's some pictures, and then there's the original manuscript, which is the same story, except written in a horrible font. So that supposedly is The Matrix. Now, I was going to read some of my book, but I think my throat is a bit dry, so I think I will leave that for tomorrow. Yeah. And then I will take maybe another break, I've received something today that has given me great inspiration, not just inspiration, but moral support for what I'm writing. But I have to absorb it. I have to take it on board, and it's very interesting. I will include what I'm just talking about in the book in its entirety. I will include what I received today. Yes. So tomorrow I will read some chapters from my book, or a portion of my book, and then I will get writing. I think by tomorrow I will have absorbed and considered for long enough. Anticlimactic, Gamer Tamer, just slightly, and then everything is great. Bye. Just, that was supposed to be the Matrix. That woman has been going around telling people that she wrote the Matrix. What I just read, which I'm going to show you, from the forward, to the end. In the beginning there was light, except, remember, she's actually saying, and everything that was light became dark because the dark was now great. The entire universe is no longer engulfed in darkness. Oh, sorry, no. And because it's no longer black, harmony once again established. Racist. What I just read to you, out of this book, this is the entirety of the story, written with large font and double line spacing, nice and big. Some of the pages that I was reading, I'll show you, like this is one chapter, an entire chapter, and that's the introduction. So out of this, a lot of this is padding. Now, let me just show you how many images that take a whole page. So out of the padding, you have this whole page is padding, this next whole page is padding, this next page is padding. I think there might be another one. Oh, that is padding. That's padding. And it has nothing to do with the story. The images have nothing to do with it. They're just images that somebody has done. Nothing to do with the story. So there's repetition of that story over and over. And then half of the book is the woman showing evidence that she has sued to claim that she has written the Matrix. Sophia Stewart. If any of you are ever hearing of Sophia Stewart, you can let them know she's full of shit. That you've heard the entirety of the book. You can tell people to come and listen to it here. Don't bother wasting the $26 it cost for that book. You know? So, there you go. Folks, I'm going to bail. My throat is really dry. So, that's it, folks. I will see you again soon. I hope you enjoyed this. Ciao.